Hello guys, welcome back to my channel, Maison African Motives. Still working on O-level mathematics. In this platform, we shall have the question paper which was written in June 2015, which is paper 2. So we shall try by all means to finish up this paper that we are given. All right, so trying by all means to cover up everything. So in this platform, guys, that's what exactly we have, and make sure that you have got this additional material, the answer paper, the geometrical instruments for your construction, the graph papers. You've got 3 sheets, in this case, mathematical tables, or that will be a calculator. Then a plain paper, which is just 1 sheet. So that was according to this paper. Some of these papers now, they will give you in everything. It will be on the paper, but this one, it was a little bit different. And yeah, that's what we have. And even last time on our final, we had the same thing also, where we are not given this paper, or I mean, we are not given a space to answer. So that means we have to try by all means to be very, very careful when you're answering. Make sure that you write something that is visible and clear on your questions. Okay, so the first part, guys, is just direct. Here we are, it's paper 2. You have in your calculators, given to express on 1a, that is item 1, this 5/16 as a decimal fraction, and the other one as a percentage. Okay, so this is paper 2, guys. There's nothing that you're going to waste up your time here. Just punch this on your calculator. You're going to obtain something like 0.3125. All right. Then as a percentage, we know that to express as a percentage, you multiply by 100%. Okay, so this will be 5/16 multiplied by 100%. So by doing this, your answer is going to be a percentage, which is 31.25%. Or you can even take from the decimal, because remember, a percentage can be from a fraction or from a decimal. Still, it's one and the same thing. All right. Then on B, item 1, we're asked to simplify. We are on our exponents now, where we are given a 27 to the exponent of 2/3, that is to the power of 2/3, minus 1/8 to the power of 1/3. Okay, so how are we going to simplify this? We just have to simplify each separately. That is the first part. So remember from your laws of exponents that x to the exponent of a over b. Remember, I told you guys this gives us the fifth root of x and everything to the exponent of a. So it means in this case, that's what you're going to do on the 27 here. I've got 27 to the exponent of 2/3. So the 3 in the denominator here becomes the number that will be in the root. So this will be equivalent to the cube root of 27. Whatever that you're going to have, you raise to the power of 2. Minus, you do the same thing on 1/8. So it's 1/8, which is the cube root of 1/8. And whatever that you're going to get, you raise to the power of 1. That is the exponent in this case. Okay, so the cube root of 27, this is going to give us a 3. Then whatever that you get, you raise to the power of 2. So it's 3 to the power of 2 minus the cube root of 1/8. So it's the cube root of 1, which is 1, the cube root of 8, which is 2. So everything to the power of 1. As you can see, there's no effect here. So 3 to the power of 2, that's 9, minus 1/2, that is what you're going to have. And from your calculator, you can just simplify this direct, and it's going to give you 8.5. So that is what we're given in this part. And the other part we're now given on item 2, that is 3 and 4/5 minus a bracket of 1 and 2/3, whatever that we have, plus 7/15. So what we're going to do in this case, okay, we are just going to apply our BODMAS. All right, so we've got our BODMAS in this case, whereby yes, using our BODMAS, but we've got mixed fractions here. So let us try by all means to have them as improper fractions before we do any part of applying our BODMAS. Okay, so here we can multiply. In this case, this will be, all right, so we said this is our BODMAS here. So this will be times here, then we add, so it's 3 times 5, which is a 15, plus 4, which is going to give us 19. Okay, so this is going to give us 19/5. Minus, you do the same here, multiply this, then you add, so it's 3 plus 2, which is 5. So this is going to give us 5/3 plus 7/15. All right, so that's what you're going to have. So it means we can actually expand the brackets here by minus. Remember, it's one and the same thing. Or you can just combine these two first. I don't know what is best for you. You can simply multiply by a negative, which is 19 over 5, minus times this, which is negative 5 over 3, minus times a plus, which is negative 7 over 15. So that's it, guys. We can find our LCM of everything. So that is LCM of 5, LCM of 3, and 15. What is the LCM of these numbers? That is a 15. So you can divide as usual. 15 divide by 5. In this case, that is going to give us a 3. Whatever that you get, you multiply to 19. So 3 times 19, that is what you're going to have in this case, which is a take note. Okay, let me just multiply 3 times 19 here, minus, let's do the same here, 15 divided by 3, that is going to be 5. Whatever that you get, you multiply by 5. So it's 5 multiplied by 5, minus 15 into 15, that's 1 multiplied by 7. So it's going to be 1 times 7. That's what you're going to have. So let us multiply together, guys. 3 and 19 from your calculator. That is what you're doing, which is going to give us 57, something like 57 here. Minus 5 times 5, which is 25, minus 7, everything over 15. Okay, so we can subtract everything on top. That is 57 minus 25 minus 7. Everything is going to give us 25. Okay, so we're going to obtain 25 over 15. And we can reduce this part here by 5. That is 3. By 5, that is 5. So you got 3 into 5. Which is going to give us 1 and 2 over 3. So that is our answer. So it's very, very important that you have to understand the concept that you are given whenever you're answering these typical questions. It's very, very important. So you can even cross-check with the working that you have got in this case, all right? You can just cross-check with your calculator direct at once, because this part here, you have it. You can use your calculator at once to see if it is going to give you the exact thing. All right, so that was it. Let us move on to the other part, which is now on the C part, where we are given P. All right, let me just remove this part here so that we can see our C here. Okay, guys, very sorry for that. It's actually erased everything. I wanted just this part. Okay, so it's fine. We have to do it the wrong way, but I wanted it to be faster, guys. Okay, so now we are given P, which is equivalent to the 0.45, and we've got R, which is 2 times 2,513 times 10 to the power of minus 4. All right, so this is what you're given, and you're asked to express P first in standard form. That is the first part. So you have to express this in standard form. So you put our P, which is equivalent to 0,045. Remember, in standard form, our number has to be between 1 and 10. So you have to move our commas until 4,5. It is now between 1 and 10. So that means our P is 4,5 multiplied by 10 to the power of the commas that we moved. That's 1, 2 here to the power of 2. And if you have to cross-check here, we started with a 0 digit, so that means our answer is going to be a negative. Whenever you start with a 0 digit, it is going to be to the exponent of a negative. Okay, then item 2, express PR is giving the answer in standard form. PR, that is your multiplying, that is your item 2. So this was also item 1. Our item 2, you're now multiplying PR, that is P. In standard form, this P we have already expressed in standard form, which is 4,5 times 10 to the power of minus 2. Whatever that we get, we multiply to R, which is this value here. So we can multiply to the value of R in this case, right? So this is going to be 2,513 multiplied by 10 to the power of minus 4. Okay, so this is what you're going to have here. So how do you multiply? Remember, standard form, you have to multiply these numbers together. Okay, these numbers separately. That is 4,5 times 2,513, and you're going to obtain something like 11,3085. 3085. That's what you're going to have. If you multiply properly, then we're going to have this power of the base and the power is part here, base and the power, base and a power here. What are you going to do? Let us just indicate first 10 to the power of minus 2 times 10 to the power of minus 4. So remember, when you're multiplying the base, which are the same, you're going to add the exponent. So if you can see here, it's a plus and a minus here that we are having, and the plus and minus gives us a minus. So that means we are going to have 11,3085 multiplied by 10 to the power of -6 minus 2 minus 4, that's a -6. But now this answer that we have got is not in standard form because 11 comma is not between 1 and 10. So what are we going to do? We have to express this number between 1 and 10, that is move 1 comma to the left, and it's going to be 1,13085 multiplied by 10 to the power of 1. So in this case, take note, we started with a whole number, so that will be to the power of +1. Okay, so this one will be +1 because it was a significant digit. Whatever that we have, we multiply to 10 to the power of -6. Okay, so that's what we're going to have. So as you can see, we are multiplying and now back to the same thing. If you're multiplying the base, which are the same, you add the power. So we put plus and minus, which is going to give us a minus. So that is going to be 1,13085 multiplied by 10 to the power of 1 minus 6. That will be -5. Okay, so this is your PR in standard form. So that was the question, guys, as you can see. Now number 2, you're given the universal set with elements of 1 to 10. Take note here, our x is greater than or equal to 1, so which means 1 is involved, also 10 is involved because there's an equal to there. All right, so the question is, we've got the multiples of A and we've got the prime factors of 20 for B, then list all the elements in A. So A is a set that is going to be taken from what? From the universal set. Our universal set, we are given that it's 1 up to 10, which means in this case, our universal set is going to be elements 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 10. So this is our universal set. So this set A is going to be taken from this universal set, but our A is prime numbers. So we're dealing with prime numbers. So which prime numbers we have from 1 up to 10? That is a prime number. You're talking of a number that is exactly divisible by 1 and itself. All right, so we've got 2 here. We've got 3. We've got 5. Okay, we've got 7. These are the prime numbers that we actually have in this these numbers from 1 up to 10. Okay, then before you attempt this B, because as you can see, the item 2 part, it is got to do with B, so we need to find what is in B. B is actually a set of elements such that our x is a factor of what? A factor of 20. So we need factors of 20 in this case. So which factors of 20 that we have from 1 up to 10? 1 is a factor of 20. 2 is a factor of 20, 4 is a factor of 20, 5 is a factor of 20, 10 is also a factor of 20. These are the numbers that when you divide 20 divided by n of these numbers, you get an exact value without a remainder. Okay, so this is your set B. So for us to have the elements of A union B complement, take note there's a complement here, means complement not part of this, so it's not part of A union B. So what are we going to do? We are going to first find our A union B because we need a set which is not part of A and B. So for us to do that, let us first find our A union B first. We're just going to put it here. A union B is equivalent to, remember union you combine, so you're combining what is in A and what is in B. So we've got 1 here, just combine everything. So that is our set. So let's see if we got all the numbers. I'm just going to change this. Okay, let me just put this one. All right, no, this one is fine. Okay, so we've said we've got 1 here, we've got 2, okay, 2, we've got 1, 2, we've got 2. So you don't repeat these values. We've got 3, okay, we've got 4 here. Okay, we've got 5, and also 5, we don't repeat this, we just write 1. We've got 7, and we have got 10 here. All right, so these are the elements that we have in A union B. So what about A union B complement? A union B complement, now these are the elements which are not part of these, but they are in the universal set. So which numbers do we have here, but are we not having here, but they are in the universal set? So we do not have the numbers on this set of A union B, but they are in the universal set. Okay, so let's cross check from the universal set. 1 here is already there. Okay, 2, we have got 2 here. 3, we have got 3 here. 4, we have got 4 here. 5, we have got 5 here. We move on to 6. We do not have 6 in this set, so that is a complement. It's not part of this set. Okay, so we've got 6 here. We've got 7, we've got 8 here. 8, we do not have 8 in this set, so which means it's the complement 8. We've got 9, we do not have 9 here, so it's also in the complement. 10, we have got 10, so which means our set is just going to be 6, 8, and what? 6, 8, and 9. So that's the consideration. That's how you simply attempt these typical questions. All right, then the item 3 now, we need number of elements. Take note, there is n here, number of elements in A intersection B. So take note, the intersection, we say this is what is found in both A and what? A and B, both these two, okay? These two sets. So let us see our A intersection B first. So A intersection B, what are we going to have? What is in A and what is in B. Okay, so we are cross-checking from our A and B. So let us just do this part here. So let us remove this. Okay, so let's see which part is in A and is also in B. Okay, so this is it, guys. We've got 2 here, we've got 2 here. So that's it. We've got 5 here. Yes, we've got 5 and 5. So we've got this. We do not have any other number that we are seeing, which is the same. So now the question is, how many elements are these? That is number of elements. How many are there? So we count 1, 2. So we've got 2 elements in this case. All right. Then draw a clearly labeled Venn diagram to show all the sets and their elements. Okay, so for us to draw this, we need from the universal set. Okay, we're going to take everything from the universal set. But before that, let us come back here. We can see that we've got an intersection. That's the first thing. A and B, there's an intersection. Also, here when we had A union B complement with elements which are outside of A and B when they A or B when they are combined together. These elements, they are outside of the set. So it means from our diagram, we are going to have an intersection. That is what is important. We are going to have an intersection. We saw that the elements on the intersection are there between these two sets A and what and B. Also, we saw that there are elements which are not part of A and B. So where are we going to place these elements? These are the elements that we are going to place outside of the what these two sets, that is outside of the universal set. So that's it, guys. You just indicate your universal set sign, that sign that you've got here. I don't know if it is clear, or you can prefer something much better to indicate this. Okay, so the easier way, start from the intersection here in between A and B on the intersection here. Start from this intersection. All right, so make sure I start from there. So let us start with the intersection of A and B. Take note, this is our intersection here, A, intersection B, we said we've got 2 and what? 2 and 5. So these are the elements that we are going to insert here. That is 2 and 5. We are done. Now we are asking yourself, what is going to be left in A? If you take 2 and 5, what are you going to remain with from A? So let's get back to our A here. Take note, we have taken 2 and 5. So we're going to remain with what? With 1, 4, and 10. So these are the numbers that you're going to remain with in A, which is 1, 4, and 10. So we've got 1, 4, and 10. You move on to B, you've taken 2 and 5. So what is going to remain? So let's get back to our B. Here, this is our B here. So we have taken 2 and 5. So we're going to remain with, okay, our B here, guys, our B. We've taken from B, not from A. Here I've taken from B. This is our B, which is this 1, 4, and 10. Okay, all right, 1, 4, and 10. These are from here. So I hope someone saw that we took this from the wrong part. This is 1, 4, and 10 here. 1, 4, and 10. In B, in A, we have to go back to our A. This is our A here. This is your A with 2, 3, 5, and 7. So we're going to remain with 3 and 7. All right, so we're going to remain with 3 and 7. Okay, so we've got 3 and 7 here. All right, now from this part, we have to ask ourselves now, do we have elements which are going to remain outside? Okay, those are the elements that we indicated from A, union B complement here when we listed this part here. All right, A union B complement, these are the elements which are not part of A and B, part of A or B. So we put 6, 8, and 9. So these are the elements that we are going to represent outside of the set, which is 6, 8, and 9. So if you have to see all the elements that are here are in the universal set. So if you see these numbers and you cross-check from universal set, then you have elements which are not in the universal set. Then it means you have done something that is wrong there. All right, so that was the question, guys, on this part of having the Venn diagram. So as you can see, the whole of this part of set, it was actually having 7 marks, that that part of set alone. So make sure that you revise your sets, guys. These questions, they do come. They can ask any question on sets pertaining this part, so you have to be very, very careful. All right, so let's see the other part that you're given in this case, which is B part, to solve the equation. So solve the equation. I've got 3 marks for that, to solve this equation. Okay, so I'm just going to put this aside here. So let's just copy it down. Then we will shift this a little better. So it's 3x plus 1 over 3 minus x minus 4 over 5, which is equivalent to 1 over 2. That is equal to 1 over 2. Okay, so how are you going to solve this equation, guys? And for this equation that we are given to solve. Okay, so it's going to depend with what is the best for you. You can actually clear fractions here. You can just clear fractions. How am I going to clear fractions? I have to find the LCM of 3, 5, and 2. And the LCM of these 3 numbers is actually 30. So I can use 30 in this case for 3, 5, and 2. So I'm just going to multiply this by a 30. I'm just going to multiply this by a 30 here. Multiply this by a 30. Okay. So if I do this, I'm going to obtain these 3 into 30 here, which is a 10. So I'm going to remain with 10. So it will be 10 into 3x plus 1 minus, we do the same here, 5 into 30 here, that's a 6. So we're going to have a 6 here. So it will be 6 into x minus 4, which is equivalent to, do the same, 2 into 30 here. That is going to give us 15. So 15 times 1, that is a 15. So we can actually expand brackets, collect like terms. So we've got 10 and 3 here, which is 30x, 10 and 1 here, which is plus 10. If you multiply, minus 6 times x, that is negative 6x, negative 6 times negative 4, that is positive 24, is equivalent to 15. Okay, so collect your like terms. Which like terms we have? We've got 30 and 6. So you can subtract here 30 minus 6, which is actually 24x. So this is going to give us 24x. Then we've got these 2 numbers, 10 and 24, they are adding, and these are going to give us positive 34. If you add it properly here, equal to 15. So that's it. That's what we're having, guys. Then we can at least collect the like terms again. That is, we have to transpose the 34x to the other 34 to the other side of the equation is going to be negative 34. So that means here I'm going to be left with 24x is equal to 15 minus 34. So I'm now subtracting these two, 15 and minus 34, which is going to give us negative 19. Okay, since I need x, what am I going to do? Divide by 24 both sides. So that means our x is going to be negative 19 over 24. So that's what you're going to have for the value of x, which is negative 19 over 24. So as you can see here, you can't simplify further. There's nothing, you can't reduce these values. You just have to leave your answer like that. Okay, so that is what we actually had from this part. Okay, sorry, let me try to shift again back to that part. The 3a, on 3 number a, we are given, it is given that 300 keto are to be shared in the ratio of 12:10:8. Express this ratio in simplest form. So how do you express this ratio in simplest form? All you need is to reduce these values. You just need what is common between these numbers, 12, 10, and 8. So here I'm just going to use 2. Reduce this by 2 here, by 2 here, by 2. So what are you going to have? That's 2 into 12, which is 6. As to 2 into 10, that is 5. 2 into 8, that is 4. So this is the simplest format that you are asked to write. Okay. Then the third part is to calculate the difference between the largest and the smallest shares. Okay, so this is your largest share according to the ratio. We've got 6. The smallest share is 4. So what are we given? We have to find the total ratio because we are given 300 keto here. So we have to find, according to the total, 6 plus 4, that's 10 plus 5, which is 15. So 15 according to ratio is the one that is giving us the total. This one is for the total. So it's the one that we are going to equate to 300 keto. So what about 6, which is the largest? Because we need the difference. We have to find the largest first, which is 6 is equivalent to what you do not know in this case. So that will be less. So as you can see, to find this is going to be 6 over 15. So it was 6 over 15 multiplied by 300. And if we do this, we are going to obtain 120. So these are 120 cattle that we are having. We do the same here for the smallest shed, which is 4. So we've got 4 here. We just do the same like what we did here. Since 15 is equal to 300, what about 4? What are we going to get? So it's still the same. It's going to be less. So it's 4 over 15 multiplied by 300. So we're going to have 4 over 15 multiplied by 300. Okay, so if you multiply this, 4 over 15 multiplied by 300, you're going to obtain 80 cattle. Okay, so now the question is, what is the difference? So the difference now is we got 100 from the first one, and from the second one, the smallest, we got 80. So now that is your difference. Difference, subtract. That is what you mean. So if we are to subtract, calculate the difference between the largest, we're going to obtain 40. To be 40 cattle here. That is your difference, if I'm not mistaken. Or now, just cross-check your numbers also using your calculator and so forth. See if you are in the same aspect here. Then the B part we are given, there's an advert in a shop which reads Valentine's special 25% off all red shirts. So this is what we're given. Every red shirt on that particular day, it was being sold at 25% less. That is off, which means you are removing 25%. The red shirts were originally marked, that is the original price, it was marked $25 each. Joko bought a red shirt. Calculate the amount that Joko paid for the shirt. So there's a guy who is referred to as Joko in this case, and this guy had to buy a red shirt. And when you bought this shirt, what is the price? What is the amount that is going to pay now? Originally, it was a $25, but remember, when he enters the shop, he's seeing this advert that to say is 25% on all red shirts, and he also bought a red shirt. So what are you going to have? We're just going to find 25% of this, then we subtract from what? From $25 since it is off, okay? So that is the case. So let us just do this. There are so many ways that you can actually do. So we are going to find that 25% of the amount that is the shirt is costing, which is $25. Okay, so 25% of $25 gives us something like 6.22. This is paper 2, guys. Use your calculator. You're going to obtain $6.25. So this is the amount that you're going to remove from what? From $25. So at the end, Joko is going to pay $25 minus $6.50. So it will be 25 minus $6.50. Okay, so what is the amount therefore that is going to pay, which is $18.75. Okay, so that was the case. Or you can actually do this way. You can put this way. Remember, I told you that percentage originally is marked at 100%. So at 100%, that is your original price, which is this amount. You're saying at 100%, the t-shirt, which is a red t-shirt, is costing the shirt that we are buying here, it's costing $25 at 100%. So this is what we have got at 100%. Now 25% off, which means we are subtracting 25% from the 100%. If we subtract 25%, what are you going to remain with? We remain with 75%. So what is the price at this 75%? You do not know. So that is the question that you're asking yourself to say, at 75%, what then is going to be the price of the shirt? So since we do not know this, we have to apply our simple proportion. This is going to be lesser here, so we've got less. So from this part, since it is less, we take the lesser value, which is 75 over the bigger value times $25. What you want is the one that you write on top here. So since it's less, you write the lesser part. So if you multiply 75 times 75 of 100 times $25, this is going to give us $18.75. So still we are obtaining the same answer from this particular person, even if we've got different ways of answering it. Okay. Then on number 2, Tino bought 10 such shirts and sold them at $23 each. Calculate the total profit. It's what Tindo. Okay, this one is Tindo. We had to buy 10 on that day. So that is what we've got. So we can ask ourselves to say, from the shirt that we have got in this case, how many shirts are we going to have? We can calculate the total amount that Tindo bought these shares. Remember, each share, when 25% is removed, the share is now costing what? $18.75. And this guy had to buy 10 of them. Okay, so we are saying this is now item 1, item 3, or item 2. Okay, let's just say, I think it's item 3 or item 2. Let me refer back. All right, so this is item 2. Okay, so this is our item 2 here. So we are saying you bought 10. Remember, each share is now at $18.75. So you bought $18.75 multiplied by 10 t-shirts, 10 shares that he bought, which is going to be $187.5. But since this is money, you just put a 0 here. So this is the amount that you had to buy the shares at this price. Okay, then what happened is now selling these shares now at $23 each. This is the selling price. So we want to know how much did he get, how much did Tindo get from what? From selling these shares at what? At $23. So $23 multiplied by 10. Remember, these are 10 shares that are being sold. So it's going to be 10 times, which is $230. So $230 like this, or you can just write 230. So this is your selling price, and this is your buying price. So what is going to be our profit? Remember, our profit is going to be the selling price minus the buying price, okay? So our selling price in this case is the $230 minus the buying price, which is 187.50. Okay, so that becomes your profit now. So the profit is going to be, if you subtract properly, this will be $42.50. So that is the profit that was made by what? By Tindo, the total profit. Take note here, the question is asking for the total profit, not the profit of one share. If it was profit of one share, you work with one share to say originally the share was costing this, then you work with that. Or what we can do is still we can do this way. This was not the only way we could have done this way, since we know that this shirt now is costing $18.50, which is one shirt that we have got here. We can work from that one shirt to say one shirt actually was bought at $18.75. This is for one shirt. Okay, so we are saying our buying price for the shirt in this case is $18.75. This is for one shirt. Okay, then the selling price for that same shirt. Okay, so this is a shirt here. So something like this. So this is our buying price. Then what about the selling price of that same shirt? Okay, this is what we've got. We are referring to one shirt here. Each is going to be sold at what? At $23. So that is the selling price, which is $23. So it was now sold at $23. So what is the profit? Remember, our profit is the selling price minus what? The buying price. So we're going to subtract 23. 0.00 minus the buying price, which is 18.75. Okay, so let's try to do our calculations. That's 23 minus 18.75, which is something like 4.25. Okay, so this is $4.25. Okay, so this is the profit of one shirt. Remember, we are referring to a single shirt now. We are not working with everything. It's just a single shirt that you are working with. So if this is the profit of a single share and this guy had to buy 10 of them, then what was the profit for these 10? So that is why we have to ask ourselves now is, if it is 10, what is going to be the profit? So therefore the total profit will be $4.25 multiplied by 10, which is going to give us 42.5. But this is money. You just put another digit so that you've got 2 decimal places after the point. Okay, for cents. So that was it, guys. As you can see, so many ways that you could have done or you could have used to answer this particular question. So that was our item B. That is what we had on item B, and it was actually 6 marks. Everything there, it was actually 6 marks. Okay, so let's say the other question that we are given, in this case, we are now on circle geometry, where we are given a circle, in this case, which is question number 4. The diagram below shows points on A, B, C, D, which are on the circumference of a circle. Center, or the moment you're given a circle with a center, that means try to apply everything about a center. For the diameter from D to B here, that's a diameter, and we know that a diameter subtends an angle of 90 degrees at the circumference of the circle, so which means this angle here, it will be 90 degrees. All right, so that's what we get from this. Do we have any part where it is subtending an angle? We do not have, so that's it. Then we are given the angles 40 degrees and 50 degrees, 30 degrees actually, and a tangent to the circle here, which is EFAF. EIF is a tangent, so remember a tangent, it just what touches the circumference of the circle. So you also need to know also the theorems that you have when you're dealing with what? When you're dealing with a tangent. Okay, so what is the first equation? Let's cross-check our first equation here. The first equation is to calculate ADB. So we need angle ADB. Okay, so this is what we need. That's our first item. That is A to D to B. Okay, so this is your ADB, this one. Okay, so what are we going to do to find this angle ADB? So there are so many ways actually that we can use in this case, but in this case we could have just worked from the tangent. Remember, angle between a tangent here and a chord, take note of the chord, this chord here, AB, is equal to the angle in the opposite segment. Is between the tangent and the chord. This is the angle between the tangent and the chord. So it is equal to the angle that is being created. What you do is that you take this chord AB to the circumference. As you can see, it is creating angle at what? It is creating angle at D. So this angle created at D is the same as this angle that we are referring to as what? As 40 degrees. Not only there, but also at what? At C, which means also at C here, the angle that is created at C is going to be 40 degrees. So that is what you are having. So this is 40 degrees. This is also 40 degrees angle between a tangent and a chord. So that is the concept that you have to use in this case. All right, so which means this angle at D is going to be 40 degrees. So that is our angle AD, ADB. In this case, this one is going to give us 40 degrees. All right, then the other part, DAE, item 2, that is angle DAE. Okay, so let's try to locate our angle DAE, that is from D to A to E, this angle here that is being created, this part here, that is our DAE, this one. All right, so that's our DAE. So how are we going to find our DAE? This is what we have got, guys. I want you to see, we said this angle here is 40 degrees. We have got 40 degrees, and the whole of this angle combined this 30 here and this angle combined together, we said this angle is what? 90 degrees. We've got a right angle here, that's a right angle. So we are just remaining with one angle from a straight line, because EAF is a straight line, it's a tangent, and a tangent is a straight line. So what are we going to do? Angles on a straight line, they end up to 180 degrees. So we can use that advantage. So it means angle DAE, is going to be 180 degrees minus the angles which are lying on the circumference of a circle. Sorry, on the line, not on the circumference, but on the line. And which are these angles? We said we've got 40 degrees, and what other angle? 90 degrees. Okay, so you do not take the 30, you just take the 90, because 30 is inside of this 90. It's combined by the 90 degrees because it's covering the 30. So you do not repeat that 30 because already it is being covered by this 90 degrees. All right. So you just subtract these two, which is going to be 180 degrees. If you add this, it's going to be 130 degrees. If you subtract, that will be 50 degrees. Okay, so this angle here is 50 degrees. That's it. And if you have to apply the same concept here that we talked about, angle between a tangent and a chord, you're going to see that also the angle that is going to be created at B here is going to be 50 degrees from this angle that we've just taken. Okay, so as we just needed DAE, and we say DAE is going to be 50 degrees. All right, so this is 50 degrees. Item 3, ABF. So we need angle ABF. So that's the angle here, AB to FA. BF, this angle here, this is the angle that we need. So how are we going to find angle ABF? All right, so it's very, very important that we have to understand, guys, our triangles and everything. We have to understand every concept very, very much. Okay, I want you to see something here. we can find this angle at F, but it's going to take us time. It's fine, it's going to take us time. We're going to find this angle at F. There are so many ways that we could have done this, but I think this one can work easier. We can find angle at F. How can we find this angle at F? I want you to see this part. There are so many ways actually that you can use, but I want us to take this part here from A to F here, from A to F, then B here to C, back here, the triangle that we have created. So on this triangle, you know that angles in a triangle, they add up to 180 degrees. We know that angles on a triangle, they actually add up to 180 degrees, okay? So that means we can calculate this angle. Like I said, there are so many ways. I'm going to use another way, but we can calculate this angle here, which means here, remember I said we've got 90 degrees, which combined 30 here. So which means here we're going to remain with 60 degrees. 90 minus 30, this one, that's a 60. So we are now having, we are going to use the whole of this angle now, which is 60 plus what? 40, which is 100. So this angle is now 100. So to find this angle at F, we are going to have 180 degrees angles in a triangle, which is triangle ACF. So we subtract these angles, which is 40 degrees here, plus these two angles, which is 60 and what? And 40, which you said is just, that one is just 100. Okay, let's just add 60 and 40. So it's 60 and 40 there. So we are going to have 180 degrees minus, that's 100 plus 40, which is 140 degrees. So if we subtract, we are going to obtain 40 degrees. So this is actually 40 degrees. So to find now the angle at B, this one that we need, which is ABF. So therefore, ABF now is going to be using also the concept of angles in a triangle. We know they add up to 180 degrees. So what are we going to do? We are going to subtract these two angles now, the 40 and the 40, because these are the two angles which are in this triangle. So we're going to obtain our answer there is 180 minus 40 plus 40, which is 80, and this is going to give us 100 degrees. Okay, so that's our angle ABF, which is 100 degrees. So like I said, there are so many ways. Which other way could we have used in this case? Okay, I want you to cross-check this other way again. We can see that from this concept, I'm just going to remove this. Yeah, let me remove even this part is fine. Let's remove this. Okay, is it going to work if I remove this also? Okay, let me just remove this. I hope I'm not removing the angle that I want to use. Yeah, I'm not. Okay, let me remove also this. Okay, let me just remove this part so that it can be clear. But remember your 50 degrees, guys, that one that I showed here. I'm just going to work with that one. Remember, this was 50 degrees here. I want to work with this angle. Okay, this is the angle that we want to find, this one at B, this angle here. Okay, so the other way that we could have used is that from D to C, here we've got a chord, or you can work with the arc. Remember, we've got a chord and arc at the same time. The DC, this one, it's an arc. Then this one, it's a what? It's a chord. So you can work with either of these two. But we know that the angle subtended by a chord or the arc, which is the same chord or the same arc, they are equal at the circumference. So if you have to cross-check where this chord is subtending, it's giving us angle here at A and also at B here. This is where, if you cross-check here, creating angle at A, you're also creating angle at what? At B. So if this is 30, it also means this angle at B here is also 30 degrees. Okay. But CBF is a straight line. So we can take advantage of these two angles that we have, since we've got a straight line, since we know that angles on a straight line, they actually add up to 180 degrees. Okay, so this is what I'm going to do. I'm going to subtract these two angles, the 30 and the 50. So if we add 30 plus 50, that's 80. As you can see, 180 minus 80, we're going to obtain the same 100. Okay, so that was the same answer that you've got here. We are simply saying 180 degrees minus these two angles that we have got, which are on a straight line. So it's 30 plus 50, and that would be 180 minus 80 degrees, and that's 100 degrees. So as you can see, that's the same answer like the one that we just got. So it's very, very important, guys, to know your theorems. It saves you time in exam if you know your theorems. Okay, then O, CDB, not O, it's CDB. That is the fourth part here, CDB. So let's cross-check our CDB. That is this angle here, CD to B. So this is the part that you're going to work with, this one, CDB, this one. Okay. So what are we going to use this one? If you cross-check, do you remember we said this is our 90 degrees, the whole of this angle, and we ended up here having 60 degrees. Okay, I want you to see that CB, this chord CB, this one, the chord CB, is creating an angle at the circumference at A here, it's creating an angle of 60 degrees. The same CB is also creating angle at the circumference at D. So you know that angles subtended by the same chord at the circumference are equal, so this will be 60 degrees. All right, so that will be the concept there. So that angle was going to be 60 degrees. Okay, so that was the case for this question. B item 1, we are given now to convert 65 in base of 10 to a number in base of 3. So this one is from your paper 1, guys. You know how to convert a number from base 10 to any base, whereby I told you that you just divide by the base throughout. Okay, so this is what you're going to do. We have got 65 in base of 10, so this is it, 65 in base of 10, divide by the number that you're converting to, which is 3, noting all the remainders down. So that is the case. So let us divide, guys. 3 into 65, this is 21, into 63 is going to be 21, guys, which is, can you divide 3 into 6, that's 2, 3 into 5, that's 1, remainder 2, okay, 3 into 21, that is 7, remainder of what, there's no remainder, that's a 0 here, 3 into 7, that is into 6, that's 2, remainder 1, 3 into 2, that's a 0, remainder 2. So this is your answer. Remember, we said we take our answer from the bottom going upwards. So it means our answer taking from the bottom going upwards. Here we're going to have 2, 1, 0, 2. So that's what you're going to have in this case. So this is 0 here. In base of what? In base of 3. So this answer is now in base of 3. So that was it, guys. Just to convert this, then you can simplify it just by taking this. Okay, then the other part now, simplify 3, 1, whatever that you have got in base of 4 plus this number in base of 2, giving, this is the most important part, giving the answer in base of what? In base of 4. So here we've got 2 ways that we can use, which is converting the numbers to base 10, then you add them in base 10, or you can convert this number to base 4. Since it is not in base 4, so you have to convert this in base 4. So I don't know which was best for you, but I'm just going to convert that number to base 4. Okay, so I'm going to convert that 1, 1, 1, 1, 1, whatever that we have, to base of 4. So let me just do it here. All right, so these were the numbers that we were given. Remember, we're given 3, 1, 0, 2, base 4 plus 1, 1, 1, 0, 1, base 2. Okay, so I'm just going to convert this since our answer is needed in base of 4. So I'm going to just convert this to base of what? To base 4. Remember the concept, for you to be in base 4, you can convert first to base 10. Then from there, we convert to base 4. So how do you convert to base 10? Remember, raising the number in the powers of the base, which is 2 to the power of 2. 4, 3 to the power of 4. So we're going to multiply this here. All right, so it's 1 times 2. So let us convert it here. I'm just going to do the conversion here. 1 times 2 to the power of 4 plus, we move on to this one here. It's 1 times 2 to the power of 3. Okay, plus this one here, which is 1 times 2 to the power of 2. Plus, here there's a 0 here. So any number times 0, that's a 0 here. So which means I've got nothing. Then we move on to this one, it's times 2 to the power of what? Times 2 to the power of 0. All right, so that's it. We can simplify further. 2 to the power of 4, that is going to give us 16. 16 times 1, that's 16 plus 2 to the power of 3, that's 8. 8 times 1, that is 8 plus 2 to the power of 2, that is going to give us 4 plus 4 times 1, which is 4 plus a 0 here plus 2 to the power of 0, that's 1. 1 times 1, which is 1. All right, so that's it. We can add our values together. That's 16, everything. We're going to obtain 29, which is now in base of 10. So that is it, guys. Let us now convert to base 4. How do you convert to base 4? Remember, that is the previous concept that we did, divide by the base, noting the remainders down. Okay, so 4 into 29, that will be into 28, will be to the 7 times into 28, remainder 1. 4 into 7, that's 1, remainder 3. 4 into 1, that's a 0, remainder 1. So our answer, remember, is taken from the bottom going upwards. So it's going to be 1, 3, 1 in base of 4. So what have we done? we have converted this number here to base of 4. So it's going to be easier for us now to add these numbers because we are already given this in base of 4, which is 3102 base of 4, plus this number now that you've converted to base of 4, which is 131 base of 4, like this. All right. So remember your addition, guys, of number bases. Let us add our numbers here. 2 plus 1, that's 3, and it's direct. This one is less than the base, so you can just write it. 0 plus 3, that's a 3. 1 plus 1, that's a 2. 3 plus 0 here is a 3. So this is your answer. So as you can see here, there was nothing for you to divide or to do because the numbers, they are already below the base or lower than the base. So there's nothing that you're going to do. Just leave it like that. So like I said, guys, you can convert this to base 10. I want you to try that method. Convert this to base 10. Then you add to this one in base 10, 29, and the one that you have. Then you convert your answer now to base 4. So that is the case. Okay, so yeah, there are so many ways actually that you can have. Number 5, we are now given, so this was just 4 marks here. Okay, so let's just move to number 5. It is given f of x is given by 3x squared. This is 3x squared minus 7x plus 1. That's so f of x. So the first equation is to find f of minus 1. So what does f of minus 1 mean? In place of x, substitute minus 1. Okay, so this is our first item here. F of minus 1, in place of x, I'm going to substitute minus 1. So it's going to be 3 into negative 1 squared minus 7 into negative 1 plus 1, like this. Okay, so negative 1 squared, that's positive 1. Okay, you can use your calculator direct, guys, or just simplify everything. You're going to obtain 11 there, but this was going to give us 3 times 1 plus 7 plus 1, like that. Okay, so this is 10 plus 1, which is 11. So that's it. Then the item 2 part, we are now given item 2 to find the values, that is to solve. Whenever you're given this, find the values you are solving for x, okay? So find the values of x for which when f of x is equal to minus 1. So what does this mean? You are going to take your f of x, this is your function here, f of x, which is 3x squared minus 7x plus 1. That is our f of x. Now they are saying this f of x this time, it is equal to minus 1. So you equate that f of x to minus 1. So by doing this, you have formulated an equation that you're supposed to solve. I don't know, you're going to use quadratic formula, you're going to use which method, but it's a quadratic equation. So what's the first step? Transpose the negative 1 to this side is going to be a plus 1. So which means you're going to be left with 3x squared minus 7x, 1 plus 1, that's a 2, which is equal to 0. All right, so you can use factorization, quadratic formula, but if you are not given like to 3 decimal place or this, you just use your factorization. Okay, so I want you to try quadratic formula on the other side, but I'm just going to use factorization here. Multiply the first term and the last term. Since the coefficient of x squared here this time is not 1, so we have to multiply this, which is going to give us 6x squared. Okay, so which terms are we going to use in this case that we multiply them? They give us 6x squared, but if we add these two terms, they must give us the middle term, which is negative 7x. So which two terms? We've got negative 6x, we've got negative x. So these are the two terms that I'm going to work with. So in place of negative 7x, I'm going to substitute with these two terms, which is negative 6x, negative x plus 2 is equal to 0. All right, I've got 4 terms now, so I can factorize the first two terms. What is common here? I've got 3x. So it's 3x squared divided by 3x, that's an x. Minus 6x divided by 3x. So as you can see, x and x will cancel. So it's going to give us a negative 2. All right, so let's just allow it to auto-save a little bit here. All right, okay, I think it's back now. So let's remove this. So it's going to be a negative 2 here. Okay, so what you're going to do is that you have to factor out what is common in the second part, that is this one, and the bracket has to be the same as this one. So what are you going to factor out? Since this x is a positive, as you can see, it's a positive, so we have to factor out a negative from this part so that it becomes also a positive, this x. So we factor out negative 1, negative x divided by negative 1, that's positive x. 2 divided by negative 1, that's negative 2 equal to 0. So as you can see, the two brackets are the same. So what do? I have to factor out the common bracket x minus 2. I'm left with 3x minus 1. In this case, equate this one to 0. All right, so from these two brackets, it's either one of these brackets must be equal to 0. So it's either x minus 2 is equal to 0 here, or 3x minus 1 is equal to 0. So transpose the minus 2 here, x is equal to 2, or 3x is equal to positive 1 if I transpose. So here I can divide by 3, all right, so what are you going to have at the end? That means our x in this case is going to be 2, or our x is going to be 1 over 3, since this can cancel, so it's going to give us 1 over 3. So that is the case, guys, that you just had. In this case, you'll be given to simplify. So make sure that whatever that you are solving there is direct. What are you doing? Working with the equation, it's a quadratic equation, so I have to know my quadratic equation. If I'm using the quadratic formula, I have to know my quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So know your formula, guys. That means your a in this case was going to be 3. Your b in this case was going to be negative 7, and your c in this case was going to be 2. All right, so that's it. You can insert your values here, which is x is equal to minus b. Take note, is minus the b, which is a negative, so it's minus 7 plus or minus the square root of b squared. Make sure that you square the negative like this in a bracket, okay? Minus 4ac. Sorry, our a in this case, that's a 3. Our c, that's a 2. So we're going to multiply like this, everything over 2a, which is our a. We said it's a 3, so it's 2 times 3. So that was it. You can simplify further. Plus and minus is going to give us a plus. Let me just do this a little bit. Okay. So here we're going to have x is equivalent to minus and minus, that's plus 7, plus or minus the square root of. So use your calculator to simplify everything under the square root, which is negative 7 squared minus 4 times a, which is 3 times 2. So in this case, I'm going to obtain something like 25. So this is 25 here over 2 times 3, which is 6. And we know that square root of 25 is 5, so we're going to have 7 plus or minus 5 over 6. So how am I going to find x separate now? Because I'm having plus or minus here. So I'm going to separate the first one with a plus. That's 7 plus 5 over 6. Or the other one now with a minus is going to be 7 minus 5 all over 6. So that is the case in this part. Okay, so let's simplify further. 7 plus 5, that is 12, not mistaken, that's 12 there. So we're going to have 12 over 6. So 12 over 6, which is 2, or x is going to be 7 minus 5, that's 2. So it's going to be 2 over 6. And if we reduce this, it's going to give us 1 over 3. So this is going to be 1 over 3. So these are the values of x that we are going to have at the end. So as you can see, guys, these are the typical questions. It depends with the method or formula that you're going to use to solve, but make sure whatever method that you use, you know exactly how to apply the concept. Okay, so that was it, guys, for this particular question, which was on 5A, item 2. Okay, so let's see the other part of the question. Number 5, we are now given P is formula. We are given the formula for P, that is express A in terms of D, whatever that you've got there. So it's a change of subject. Remember your change of subject, guys. So we are going to work with our change of subject. So let us put this aside. I'm just going to retake this one as it was before. So we are given that our P is equivalent to, this is what we've got. P is equivalent to N over 2 into 2A plus n minus 1 times d. So that is what we were given from this one. And we are given to make A to be the subject. That is, express A in terms of this, that is, make A to be the subject. So what are you going to do, guys? We can clear fractions, yeah, because there's 2 here, so you can just cross multiply or just multiply by 2 here to remove this 2 here. Just multiply by 2, multiply by 2 here. So the 2 and the 2 can cancel. So for 2 times P, which is 2P, is equal to, you're left with n into 2A plus n minus 1 times D. Okay, so this is n minus 1 times D here. So this is n minus 1, all right, times a D. All right, so let's hope everything is there. In this case, we have got n, which is outside of the bracket, the d, which is also outside of the bracket. So what do I do? I expand the inner bracket first. The inner bracket, which is the smaller bracket, this one, this is your inner bracket. So let's expand that inner bracket first. So 2p is equivalent to n into 2a plus d times n. That's dn, d times minus 1, that's minus d, like this. Okay, so I've expanded the inner bracket by d. What am I left to do is to expand this bracket by n. So I can expand by n, or you can divide by n if you want, but in this case, I'm just going to expand by n. So I'm going to have 2p is equal to n times 2a, that is 2an. N times dn here is going to be plus dn squared. Take note is n and n, so it's going to be dn squared. dn here times this minus d is going to be negative dn. Since I want to make a to be the subject, I have to transpose all terms that do not contain a. And which are the terms? 2p transpose dn squared to this side is going to be negative dn squared. Transpose the positive, the negative dn is going to be positive dn on this side, which is equivalent to 2an. And I want to make a to be the subject. And what is affecting a now is 2 and n. How are they affecting? They are multiplying. So how do I remove? I have to divide. Opposite of multiplying, you divide both sides by 2n. So by doing this, we can cancel this part. That means our a in this case is going to be 2p minus dn squared plus dn everything over 2n. So that is what you're going to have at the end if we are to make the subject of the formula, our a to be the subject of the formula. In this case, all we needed, these are the steps that you actually needed in this case. So it depends with the presentation, guys. It depends. And even someone can even factorize this part, factor out this. Yeah, it's fine. You can do whatever that you feel like, but as long it is in the right direction. Okay. Now we are asked to find the value of a, given that n is 10, d is 4, and p is 20. All right. So how do I answer this type of a question? I have to substitute these values, n which is 10, d which is 4, p which is 20. All right, so I'm going to come here. This is where we are having our expression. Remember, we are given that n is equal to 10. Okay, so I just hope. Okay, let me just take this question paper. I don't know where did I put it again, but we're given that n is equal to 10. And d, our p is equal to, let's just get back. I'll just cross check that question paper if I had to open. I don't know where I put it. D is 4 and p is 20. So d is 4 and p is 20. All right. So d, that's a 4 here. And the p is equal to 20. All right, so that is what you're given. Now let us substitute this information so that we can find a. So this is now item 2 that we are now attempting. So item 2 is just a continuation. Since you want to find the value of a, you're just going to continue from where you've made the subject. So here is 2p, that is 2 times p, which is your p is 20 here, minus dn squared. So our d is 4. So it's 4 times n squared, of which our n is 10. So it's going to be 10 squared plus dn, which is our d, that's a 4. So it's going to be 4 times n. Remember, our n is 10. Everything over 2n, which is 2 times your n, which is 10. All right. So I want you to simplify everything properly. Here we're going to obtain 40 minus 400 in this case. Plus 40. All right, everything over 2 times 10, which is 20. All right, so simplify from your calculator. We are going to obtain 40 plus 40, that is 80. And 80 minus 400 is something like negative 320. Okay, so let me just wait a little bit while it saves here. All right, it's fine. So we said this is a negative 300. 6, take note, you are asked to answer the whole of this question on a sheet of part of plain paper. And use ruler and compasses only. Take note, guys, what you are given. What is working or what you're going to use is the ruler and compasses only to show clearly all the construction lines and arcs. So we have to show clearly your presentation, and also all construction should be done on a single diagram. Okay, so construction, as I told you, the first thing that you're supposed to do is to make a sketch. Okay, so in this case, we're given that there's a point M. Let me just adjust this side so that I can make a sketch here. All right, somewhere here. Okay, let me just put the question only. So this is what we are given in this case. All right, from M, which is on level ground, the angle of elevation, take note you're working with the angle of elevation of a bed on top of a vertical pole is 30 degrees. All right, so there is a point M that we are given in this case here. There is a point M. Let's say our point is somewhere here. That's our M. Remember, this is the angle of elevation, so definitely it will be on a straight line. So this is a sketch that we are having. So M is going to see from where it is here, an angle of elevation. Remember, you open, that is, you are looking on top. So it's going to be somewhere on top like that. Okay, so that is how you're going to have your angle of elevation. So which means from this point, we are going to have what? A certain angle from M going to the top of the what? Of the tray where this bed is situated, or where the bed is. Okay, that is with an angle of what? Of 30 degrees. All right, so that's what we have. So it's on the top, maybe somewhere here, we do not know, but we just know it's on the top somewhere along this line. Then from a further point N, 10 meters closer to the pole, which means we are moving from this M. We are now going closer to the pole. Maybe our pole is somewhere here. Let's just put our pole here. Let's just say this is our pole at this point, like this one. So this is angle of elevation to be at 90 degrees. Okay, so we are moving closer to the pole, which means we are going this direction. This is your pole here. But now 10 meters closer, it means maybe your N is at this point. That's where your N is situated here, and it's 10 meters closer, which means from M going this direction here, there is a distance of 10 meters, okay, to the pole. Then M and N are on the same side of the pole. So M and N, they are on the same side like this one, because this is your pole here. And the angle of elevation of okay, and we are given N on the same side of pole. The angle of elevation of the same bed is 45 degrees. So what are we referring? From this point, N is looking on the same bed with an angle of 45 degrees now. So we're going to have our N now looking at the same bed on the top here with an angle of what? With an angle of 45 degrees. So that is what you're given in this case, okay? Now you're given using a scale of 1 centimeter to represent 2 meters. Whatever, where we see 1 centimeter, we see 2 meters. So that means 10 meters is going to be represented by what? We just divide, because it's like a proportion. 1 centimeter is equal to 2 meters. What about 10 meters? What are you going to get in centimeters? We do not know. So it's 10 over 5 multiplied by what? 10 over 2 times 1, sorry. Times 1 centimeter, which is going to give us 5 centimeters at the end. So which means this on our actual diagram is going to be 5 centimeters on the part that we're going to do the construction. Okay. Construct a diagram to show the positions of M, N, and the vertical pole. Take note, it's a vertical pole that you're working with. That is why I indicated 90 degrees here to represent what? A vertical pole. Okay, so this is what you're going to have, guys. We need to sketch this. So this is our sketch. We need to construct this. So we're going to work out from this sketch that we have got here. Okay, so this is the pole and everything is there. So let us take our instruments, which we are going to use for our construction. All right, so I'm just going to take the instruments for our construction here. Remember, we are told to use a ruler. No, not this part. We do not need you for the meantime. We need a compass in this case. Okay, so you need a ruler and a compass for the meantime. So, like I said, you guys, on your construction, whatever that you're going to do must start from a straight line. It must be from a line. Okay, whatever that you're going to do is supposed to be on a line. So let us maybe reduce this, and okay, it's gonna be too big. Okay, so I'm just going to maintain as it is. So everything starts from a line. So that is where we are going to have our point. I'm just going to refer on this line here. everything starts on a line, okay, on a line like this one. Okay, so from this line we are going to mark an arc that you are going to use for our construction. So now that is where your compass is playing a role, and make sure that you are flexible with your compass to do anything that you can to change the distance here. Make sure that you are flexible on that. Okay, so you just mark an arc which is on the on this line, which is your reference point. Okay, so this is going to be my point. I'm just going to mark somewhere here. Since if I'm to cross check on my diagram here, I want you to see something on your diagram. You see everything is on the right side, so do not waste much space on the left side, because our diagram is supposed to be what from the right, is supposed to be going on the right side. So this is what I'm going to do. Now I have to mark the arc now. Okay, so from this point, just mark an arc to show this is where I'm starting with. So this is now my reference point, and that reference point in this case is what it's n. Okay, I just want to decrease the marker a little bit. Okay, do I have that part here? I do not have it. Okay, I'm just going to use it like that. I wanted to reduce the font here, but it's fine. So I'm just going to mark this point to say this is where my M is located. At M, what is happening? We need an angle of 30 degrees. Where is this angle of 30 degrees to be constructed from? Remember, guys, your construction, I told you the angles that you're supposed to know is 90 and 60. So how are you going to obtain 30? 30, we know this one was bisected from what? From 60 degrees. 60 degrees divided by 2, that is 30 degrees. So which means you are going to construct 60 degrees, then we bisect that one. Remember how you construct 60 degrees, guys? I told you that you just draw an arc of your choice. In this case, just like a semicircle. Okay, I'm just going to have it this way. Going this direction, that's the arc that I'm going to use. Just open an arc of your choice, okay? Without changing this distance, you have to step on this point, okay? The needle point, make sure it's on the intersection of the arc and the line, that is somewhere here. Then you mark back to this. I'm going to shift a little bit like this. Where these two arcs meet, as you can see, they're going to meet here. So that's where you can start marking your arc like this one. All right, so you've got your arc. This is your 60 degrees, and take note, you do not need this 60 degrees. You just need this to help you to what? To find the angle of 30 degrees. So what are you going to do with this 60 degrees? It must be a broken line. We're just going to construct this one as a broken line. So let us just have our point here. So I'm just going to shift a little bit this side. All right, so I'm just going to use a broken line. Make sure that everything is accurately given. Okay, somewhere here, guys, we can just put our diagram somewhere here, but make sure that everything is accurately given. So I said it must be a broken line, so that would be a broken line. We do not need this 60 degrees. It's just going to help us to construct the actual angle that we need of 30 degrees. Okay, so this is it, guys. I have in this case constructed my 60 degrees. If I am to measure this angle, is going to be 6, but make sure that this is supposed to pass exactly at this point. But as you can see, it's just a little bit part. Okay, so now I'm going to take my compass again, because I want to bisect this angle of 60 degrees. This is 60 degrees here. This is your 60 degrees, this one. And this is 120. Do not indicate these angles. I'm just showing you. So do not indicate those angles. Just leave it like that. Okay, now you have to bisect. Remember, guys, how we said we are going to bisect our line. We have to step on this point. Now you can choose to use this distance because it's still the same. You can choose to use that distance. So you have to mark at this point, from this point here. All right, mark an arc inside the diagram. Then you move on to the point of intersection here where the arc and the line meets. At this point, you mark an arc again. So these two arcs must intersect like this. Yes, they are intersecting. So where they are intersecting, that is where we need to join now to the what? To the point M, which is your reference point. Remember, M here is your reference point, so you have to join back to M. All right, so let's join here to M. Are we going to win here? All right, a little bit. So guys, that is what you just need in this case. All right, so I think no, it's not that much fine. It's not that much fine. If I can maybe reduce a little bit this side. So guys, you have to make sure that it's accurately presented if this software could manage us to use our hands, it was going to be easier now, guys, you see. All right, so I think now it's clear. We can join these two arcs like this one. All right, so I've joined the two arcs. That means now I have got my 30 degrees. So this is the angle now that I'm going to indicate, because it's the one that I need inside the diagram. So I can now indicate to say, all right, this is my what? This is my 30 degrees, okay? So what else do we need from this part? Let's see. From M, we said we are going to move from this point M to N, which is 5 centimeters. It was 10 meters, but we are representing what? 5 centimeters, okay? So we need 5 centimeters from our ruler here. So you have to measure on your ruler, just measure your 5 centimeters. That is, let me just do this way. Okay, let's just, okay, I did 290, not, I need 0 here. So I'm just going to make sure that my ruler is at 0. Okay, somewhere there. So now I'm going to measure 5 centimeters on my ruler. So make sure that this needle point is on the beginning of the ruler there, where, where we're not on the beginning of the ruler, but where these marks start at this point, okay? So 5 centimeters, according to us, here is at this point. This is where our 5 centimeters is. And as you can see, it's even writing 5 centimeters. So that is where you have your 5 centimeters here. As you can see here, it's written 5 centimeters there. All right, so it's 5 centimeters that I'm having. So I'm going to use this from this point now, from this point here. I have to mark an axis. So guys, it's not like you just have to see the diagram that we are having. So maybe I'm going to just increase it a little bit so that it can be bigger. So this is where your point is going to be. You just mark an arc on that point to say this is where your 5 centimeters is. On your diagram, it's going to be a little bit bigger. Or let me just try to increase this so that we can maybe somewhere, you see, that will be your 5 centimeters. Maybe this is the size of the book somewhere there, but here is because of the measurement that you'll be given. And if you put it back, it won't represent the 5 centimeters again. Why? Because we have increased our page. It's now like at 7. But this is what is important here from this part. If I am to take, it must give us the 5 centimeters that we had, because that is what we. So guys, because of the dimensions that we have got used before, now it is going to affect everything. All right, so I have to go back to the same position that I used before so that it can maintain the exact thing that it had before. So I have to maintain this 5 that I had before. Where is it? Somewhere here. Is it that 5 again? All right, I'm gonna increase a little bit here so that it maintains. Yeah, I think I'm now at the point. Yeah, this is where my 5 was. Okay, so I'm just going to use it this way, at this 0.5. Okay, so that is what is important actually, to say your diagram is not supposed to be affected by this. Okay, so that is what we had. And because we do not have any other measurements here, so it's not going to affect us. But as you can see, this part, if you try to increase and reduce, is going to affect you. So this is your N, not your M, but this will be your N. Okay, so this is where our N is situated, okay? From N, what are we supposed to have? From N, if we are to get back to our diagram here, we are supposed to have an angle of 45 degrees here. So 45 is taken from what? 90 degrees. So we need to construct 90 degrees from N, then we have to bisect that one. So remember how you construct your 90 degrees. What you do is that you step at this point, you mark an arc. Okay, it's now a little bit, I'm just going to remove this. Okay, before I just have to change to a distance that I want to use. Okay, so I'm just going to even use this one. Okay, now I can mark an arc here. So just mark an arc, just a smaller arc, and also mark an arc on the other side without changing without changing the distance. You just mark an arc like this one. Okay, so with these two arcs, I'm going now to this arc, open more than half of the line. Okay, so I'm going to open more than half of the line. Okay, so from this, I'm going to mark an arc on top here above this line. So I'm just going to mark an arc maybe somewhere here. Then I do the same on the downside, this side, on this side below. Just going to mark another arc like this. Okay, so this is what I'm having from this part. Let me just try to increase this a little bit like this. All right, so now without changing this distance, you have to step at this point. at this other arc that you constructed. Now you have to construct back to those arcs that you had before. So I'm just going to construct an arc back to this point. And also an arc down here. So they must meet at a certain point, like what they are doing. In this case, they meet at this point and this point. Then you join now using your ruler. So you need our ruler here. Let it be upright. So it is what, 270, something like this. Okay, so it's now upright. So you have to join these 2 points. And remember, this is 90 that we do not need. We need 45. So we are going to have this with a broken line. So that's where I needed that marker, which is a little bit with font that is a little bit finer than this one. Okay, so but something of this nature. All right, so our 30, let me just try to remove this 30 here. All right, let me write it here, or you cannot even write, you can even choose to not write this. I'm just going to write it inside like that. Okay, so let me get back to the line so that I can just join that part a little bit. Here, so I'm just going to have something like this. Okay, so this is your 90 degrees that you've created. So it means from this side you've got 90, you've got 90, and you want 45 degrees. So like we said here, we are going to back here and bisect. Okay, so we need 45, so we're going to bisect this angle so that we can have 45. So let us take our instrument back. Remember, guys, on your on this part here. Okay, let me. It is now hidden my instrument, guys, and okay, it's fine. I'm just going to put another one. Okay, let me see if I can be able. Yes, I managed to shift it back. Okay, so it's fine. I'm just going to take this part here and place it at this point. Since I want to bisect this angle, so remember, for you to bisect this angle, you just have to open a certain distance that you're going to use. And in this case, target where there is a point that is a little bit continuous, since it is a broken line. Okay, so you just mark an arc. I'm just going to mark an arc here. All right, I do the same on this line. I have to mark an arc which is creating 90 degrees like this. Okay, so from these 2 arcs that I've marked, this arc here in red and this arc here in red, I'm going to these points. Okay, without changing the distance that I have used to mark these 2 arcs, without changing the distance, I'm going to mark an arc inside this region here. So inside where I want to bisect the 90, I want to bisect on the right side. So that is why I have to place it on the right side. So I'm just going to mark an arc on the right side. Okay, I do the same on that point, which is on the line here. I'm going back and mark an arc also inside this region somewhere here. As you can see, these 2 arcs, they're going to meet at a certain point. Where these 2 meet, you join them back to point N. Remember, you are bisecting angle N. So you're going back to angle N. That is where you are going to have your line from. All right, so let's see if we are going to win here. Let us join. Okay, something a little bit. So I'm just going to increase. We can remove this for meantime. Okay, somewhere. So just make sure, guys, also when you're doing this, make sure that you try to be faster enough to answer this question within 15 minutes. You must be done on construction under normal circumstances, guys, because remember, you're not answering this only question. You've got a lot of questions to answer there. Okay, so somewhere here, guys, we can now join to be a continuous line. So I'm just going to use a blue one. Okay, let me use the blue one like this one. So if I join like this, okay, this is what you're going to see. So on your diagram is going to be a little bit bigger on your diagram, it's going to be a little bit bigger diagram, not like mine, like this one. Okay, so this is what you're going to have at the end. That will be a 45 degrees, this angle. So this angle will be a 45-degree angle. Okay, so that's what you're going to have at the end. And we said in between M and N, we have got what? 5 centimeters. So you write 5 centimeters, not 10 meters. This is on a paper, guys. You do not have 10 meters on your paper. You have got 5 centimeters. Okay. So now there's this part that is happening here. There is this point that we are seeing. These are going to meet at a certain point, and this is the point where these 2 meet here. And down here, because it's a vertical, we are told it's a vertical pole, so it must be at 90 degrees. So how are we going to construct the 90 degrees from the point of intersection where the bed is? So the bed is located at this point, at the point of intersection. Let's say here is your point of intersection where the bed is situated, but it must be at 90 degrees from this point. So you do not just say, okay, since I need 90 degrees, this is what I'm going to do. Where is it? Okay, I took the wrong one. Sorry, let me close this. I took the wrong one. Okay, I need this one. I want to go back to my ruler here. So because you are constructing this, you are not going to say, because I need 90 degrees, so I'm just going to take my ruler like this one. I place my ruler at this point, then draw a straight line like that. No, 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 it's not like that. Okay, because it's not going to be accurate. You have to show how you have constructed what? This 90 degrees. So this is how you construct 90 degrees from a point. Remember, guys, what you do is that you place your compass at this point where you are having what the part that you observe. Just let me reduce my diagram so that I'm not going to have this point here. Okay, this is where you place the needle point. Okay, so what you do is that you open this arc on this line, so that what you need is to have an arc like this. Let me show you. You are supposed to construct an arc like this. Remember, let me put this way, how you construct an arc from a point like this. This is a point and this is a line. So you're supposed to construct an arc like this. Then from these 2 points, you mark back on this point, you mark back here, you mark back, you mark back. Where they meet, you join them. So that is the concept that you're supposed to have in this case. Okay, so that is what I'm trying to do here. So I'm going to take this point at the needle point here. Just open a distance that I can be able to construct an arc. As you can see, if I open this distance, I am able to mark an arc like this. I can have arc here, I can have arc here. So you just open a distance that is a little bit fine. Okay, so okay, let me remove this. Okay, somewhere here. So this is what I'm going to do. Do I have an arc here? Yes, I'm going to have an arc. Go back here, I'm going to have an arc. So that is where I'm going to mark it. Just mark an arc here. From that part, it must be on the, okay, like this. Let it cross this part. Okay, a little bit. It must not be as much, guys. Okay, here let us go back and mark again. So it must pass through the like this one. Okay, so this is your arc. Then what? Without changing this distance that you see here, without changing that distance, what are you going to do? You are going to mark from those 2 arcs, which means from this arc here, you mark an arc down here. So you're going to mark an arc down. All right, just say an arc here. This is our arc down here. And we mark another one on top. So we're going to mark on, and this one on top is going to pass through the point that we did here. It's going to pass through that point. As you can see, it is passing through our point. Then we do the same from what? From this point where we intersected this bigger arc with the line. So we're going to this point now, at this point here. All right, that is the point. You mark back an arc here so that they can meet. So they are going to meet from that point. As you can see, these 2 arcs, they meet from the same point that you took from. Then also they meet at this point like this. Okay, so where these 2 arcs meet, that is where now you are going to join. So you don't just join like that, guys. No, no, no. Make sure you do your things in an accurate way, because all we need is to obtain full marks. Okay, so like this, we have created, or we have constructed 90 degrees. That means this angle is now 90 degrees. So this makes this pole to be a vertical pole. So that is what we are given in this case. So this is how our diagram is going to look like at the end. So that is what we're actually given from this question, guys. You put your M, your N, the vertical pole, and so, and also this is construction. You are not drawing a triangle that your points should be a triangle. No. Construction, let these points exceed from where they are supposed to be. Okay, do not have bigger arcs, just reasonable arcs from what, or even the line, let it be extended from that point a little bit, extended from that point a little bit. Okay, so that is what you're going to have at the end. So this is our diagram that we had. Then this question is now saying use the diagram to find the height of the pole. Okay, so we need the diagram now to give us the height of the pole. Okay, so the height of the pole is this one, according to our diagram. This is the height of the pole. But remember, because of our adjustment that we did before, it is going to be affected now on this pair. But what you're going to do, you're going to measure this height of the pole from this point here to this point here. This is the height of the pole. You measure, you answer, okay? You obtain your answer in centimeters. But remember that scale that we wrote before here, we said 1 centimeter here represents what? Represents 2 meters. So whatever that you're going to get here, you multiply by 2 meters so that it will be in meters now. So if you get 5, you multiply by 2. If you get 4, measure the distance from this point to this point, then you multiply by 2. Okay, so here it's not accurate now because of what we've done here, because adjusted our diagram and so on and so on, but that is the idea. All right, then we move on here. The distance m from the bottom of the pole. So we need the distance of m from the bottom of the pole. So where is our m from the bottom? This is our m here. So you measure from m to the bottom, which is at this point. So that is what you're going to do. From your point m here to this point here, you measure the distance, then again you multiply by 2. So that was the case, guys. As you can see, you obtain 11 marks under construction like this one. So these are the typical questions that you can have under part of elevation, angle of elevation. It can be angle of elevation, it can be angle of depression, depending with the question that you're given. And sometimes it can be a pure question on bearing. It can be actually a pure question on what? On bearing. So you must be very, very careful with these typical questions. All right. So I think that's it, guys. Let us move on to the other question, which is on question 7. Question number 7, we have got that's our section B. So on these ones, we're answering 3 questions. Now, remember, we answer 4 questions. You have to choose 4 questions, but in this case, it was 3. So m is directly proportional to d minus 1 squared. Okay, so that let us start by the statement that you are given here. We are given that m is directly proportional to d minus 1 squared. So this is d minus 1 squared. Okay, given that m is equal to 12 when d is equal to 4, calculate m when d is equal to 7. So this is another question. This is a question, but let us take this information first that we are given here. We know that we can find the value of k here if we introduce our constant, because we are going to have m is equal to k into d minus 1 squared. Then we have got the value of m, which is 12, is equal to d. That's a 4. So in place of d here, substitute 4. So it's 4 minus 1 squared times k. All right. So that's 12 here is equal to 4 minus 1. That's 3. So we're going to have 3 squared times k, which is 12 is equal to 3 squared. That's 9k. 9 times k is 9k. Then you can divide by 9 in this case. So our k is going to be, if we reduce by 3, this is going to be 4. By 3, this is going to be 3. So our k is going to give us 4 over 3. So what are we going to do with the k? Remember, we have to connect now our equation. That is from this part here, m is equal to k, which is 4 over 3 into d minus 1 squared. So this is now a relationship between 2 letters, which is m and d. So we can find any from these 2. We can find m, we can find d, depending on the question. So our question was to calculate m when d is equal to 7. So which means our m is going to be 4 over 3 into d, which is now 7. So it's going to be 7 minus 1 squared. Remember, there's a squared here. So we're going to have 4 over 3 times 7 minus 1. That is 6 squared. And this is paper 2. You can just use your calculator, or you can multiply, which is 36. And from our calculator, we are going to obtain 48. So m in this case was equivalent to 48. So that is what we had in this question, guys, as you can see. All right. Then the B part we are given, that's the shape that we have. It's actually a section, a cross section of a tobacco shed. So this one is a cross section of a tobacco shed. Remember, if it's a cross section, it means there is another cross section on the other side. So this is like a view that you see from one end. Then there's another view on the other end there. All right. So we are given that this shed is 20 meters long, which means from this view that we see to another view at the back there is a 20 meters. That is what it means. And we are given the dimensions, as we can see. The first question is to calculate the perpendicular height of C above the side BD, okay, above the side BD. So we need the perpendicular height. In this case, that's what we need, the perpendicular height of C. All right, this is our C above BD. As you can see, this is what we have. So how are we going to calculate this height here? This is the height that we need, the perpendicular height, guys, okay? If we are to see properly here, remember this is a rectangle, and here we are given an isosceles triangle, which means this side here is going to be divided into two. It was 8 before, this is 8. So the whole of this side BD was also 8. So if we divide by 2, this is going to be 4, and this is going to be 4. So that is what we are going to have in this case. So if that is 4 and that is 4, that means we are able to calculate this side. You can take any triangle, because these two triangles are actually congruent triangles. So you can just take any triangle, use your Pythagoras theorem to calculate the third side. Hypotenuse squared is equal to side squared plus side squared. So the hypotenuse in this case is the one that is opposite 90 degrees, which is 5. So 5 squared is equal to A and B. These are the sides that you are calculating, that you are given, which is this height. You can just put it as X. You can write it as your height. I don't know which one. You can just leave it as A and B. Okay, so that would be A squared plus B, which is the other side, which is 4. So that's what you're going to have. 5 squared plus 25 is equal to A squared plus 16. Then we can transpose to this side, is going to be negative. So 25 minus 16, that is 9, is equal to A squared. How do you remove square root? Introduce the square root. So A is going to be 3. So which means this height is actually 3 meters. That is what you are given in this case, all right? That will be 3 meters. Then the other part here, so in this one, we got 3 meters here. The area of the cross-section A, B, C, D, E. So we need the area of this whole cross-section A, B, C, D, E. The area of this is your cross-section. So what is the area of this shape? So as you can see, we've got a combination of two shapes, a rectangle and a triangle. So this is what you're going to do to find the area, the total area in this case. So this is item 2. So our area is going to be taken from the area of a rectangle, which is length times width, plus the area of a right angle triangle. So that one is a right angle triangle, which is half base times what? Half base times perpendicular height. So length times width here, this is our length 8, the width, which is 5. So it's going to be 8 times 5 plus, we move on to the triangle here. The base now is this side. We've got 4 and 4. Remember I said the whole of this line is 8. So this is the base. And this is your perpendicular height, which is 3. So it's half of what? It's half of 8 times 3. So that is what you're going to have in this case. So half of base, we said our base is 8 times the height, which is 3. So that's what you're going to have. 8 times 5, that is 40, plus half of 8, which is 4 times 3, which is 12. So we can add the 2. That means we are going to obtain 52. If I'm not mistaken, here is going to be 52 square meters. Okay, so these are meters. So your area is going to be in square meters. So take note, guys, of the information that you are given. All right, so I think this part we are done. We move on to the other question. The volume of the shed, which is item 3. We need now the volume of the shed. All right. So how do I find the volume of the shed? Remember, guys, this is a cross-section that you are given. And I told you guys that whenever you see that condition where a cross-section is the same as the one that you have, just like this one, you have a cross-section and another cross-section. The volume is given by the cross-sectional area times the height, or base area times height. So in this case, we found the area of the cross-section, which is this one. We calculated the area of the cross-section. We need the volume. So volume is just going to be equal to the cross-sectional area times the height, which is the cross-sectional area of what? 52 times the height. The height now is the distance we are given, that the shed, that one, the cross-section that we see here is 20 meters long, which means from this cross-section that we see here to another cross-section, we are going to have another cross-section. We do not know where exactly are we going to have that cross-section from, but that cross-section, to go to that, to have another cross-section there, we've got a distance of 20 meters throughout. So that is what they mean in this case, okay? So we are going to multiply by that height, which is the distance between the two, all right? So that's a 20 here. So 52 multiplied by 20 is going to give us 1040 cubic meters. This is volume. Just cross-check on your calculators also if we are together, guys, so that we do not go wrong in this case. All right. So that is what we had in this case. So we are just going to leave this part. Then we move on here. We are given to calculate the number of bells that are of tobacco that can be stored. So remember, these will be bags of what of tobacco that you are having. So how many bells are we going to have? And take note, guys, about this. When the shed, we have stored in the shed up to BD. So we have stored up to BD. This is where we are storing this up to BD. And each bell has got a volume of 4 cubic meters. So let us go back to our diagram. Up to BD. This is where our BD is situated at this point. So which means we are referring to this now as our cross section. This is what is going to happen here. Let me remove this part again. So that we can clearly understand each other here. Okay, this is where our BD is situated at this point. All right, this is your BD. So it means you can't store this tobacco on this part that I'm erasing here. You can't store on this part. So which means this part is no longer involved. This part, because you are storing your tobacco up to BD, up to this point. So this is where your tobacco is what is stored. So this will be your new cross-sectional area, which means we need the new volume, because remember, it's now from this rectangle and being 20 meters away. So we need the new volume up to BD. Okay, so that is what is going to happen in this case, which means we can't use this volume because this volume was using the whole cross-section, including that triangle of half pH. The triangle was there. In this case, the triangle was there. So you just need this part of area of what? Of this BD, which is 8 times 5. So that is the one that you're going to use your volume. So it means at the end, we are going to have a rectangular prism, where we know that our rectangular prism, the area, the volume is equal to the length times width times height. That is length times width, which is the area of the rectangle. Now, since you are just remaining with what? With a rectangle. This piece on top is no longer there. Forget about that piece, the rectangular piece that you see on top, because it's up to BD. All right. So it means we are going to have this, which is area of a rectangle. Remember, it was 8 times 5. So we're going to have 8 times 5 times the height. The height still remains the same. If you remove this part to say it's no longer there, it doesn't mean the height is changing, because the height that you're talking about is the how long is this cross section to the other cross section. So the difference, I mean the distance between these two cross sections is not going to change. It is going to remain as what? As 20. All right, so we're going to use 20 in this case. All right, so that is our new volume in this case. All right, so the new volume is going to be 800 cubic meters. So this is the volume where we are going to store the bales of what? Of tobacco. But we are given that each bale here has got what? 4 cubic centimeters, which means if one is equal to 4 cubic meters, how many are we going to store in this volume of 800 cubic meters? How many bales are we going to have? So this is one bale. So we just have to multiply 800 over 4 multiplied by 1, and this is going to give us 200 bales. So we're going to store 200 bales of what? Of tobacco from that distance, or from the measurement that you are now having up to BD. So guys, if you are answering questions on mensuration of solid shapes, you are supposed to understand the concept that you are given. It's not about just knowing to say, if I'm having this formula, I can no, understand the diagram that you're given. Always analyze your diagram. From that diagram, what are you given? Like this one, we have to make adjustments because we stored up to the point BD. It's no longer the whole diagram, but it's now a rectangle. It's now like this. This is what we are now having at the end. So you'll be having another rectangle this side, guys. You know your shapes like that one. So this will be now your rectangle. Now this part is no longer there. You see, the rectangle was no longer there. So that was the case. Okay, so that was it, guys. Let's see the other question. which is now on inequalities. Okay, this is inequalities question number 8. We are given that answer the whole of this question on a sheet of graph paper, and we are given that a girl is given $6 to buy fireworks for a birthday party. Take note, this girl has got $6. Okay, she buys X rockets at 60 cents each, Y crackers at 30 cents each. Okay, so as you can see, we are buying using cents, not dollars. So let us get back to our $6 and convert it to cents. So we know that 2 cents is 6 times 100 cents, which is 600 cents. So here we have got 600 cents here. All right, now it can make sense. So the first question is the rockets are referred as X. All right. Whenever we see the X, we see the rockets. So we are just going to have this X to represent our rockets in this case, and our Y in this case to represent what? The crackers. So the crackers in this case, they are represented by Y. Okay. So on A, we are asked to write down an inequality in X and Y and show that it reduces to. So remember, you have got 600 cents. This is what you have. And you buy X rockets, each costing 60 cents. So you're going to multiply 60 cents multiplied by X, plus you buy Y crackers, each at 30 cents. So it's going to be 30 Y like this. And the whole amount that you just have is 600 cents. So there's no way that you can use an amount that is greater than 600. But you're going to use an amount that is less than 600, or it can be equal to that 600. You can't exceed the amount of money that you have. If you are budgeting something, you want to buy something, definitely you budget according to the money that you have. Okay, I've got this, so I'm going to use this or less than that. All right, so that is the inequality. So I'm just going to divide by 30 so that we can reduce this by 30 here. So it's going to be 2x plus by 30 here, that's y is less than or equal to by 30 here, that's 20. So as you can see, we have formulated this inequality. All right, guys, so if there's now noise, and I have already started this video and I can't stop now, so I just have to continue, guys. Let's hope it's not going to affect much, but hope we are going to win. All right, so that was our item A. We are done on our A. Then on B, she wants to buy at least 4 rockets, at least. Remember, I told you whenever you see at least, it's greater than or equal to. All right, so she wants to buy at least 4 rockets, and the number of crackers should be more than or equal. Take note, we are given more than or equal to twice the number of crackers. Okay, so here we are now asked to write down 2 inequalities that satisfy these conditions. So we need 2 inequalities from this. Okay, so let's start from the at least here. At least 4 rockets, and we said rockets is divided by X. So it means X is greater than or equal to, that is at least, greater than or equal to. If it was at most, okay, at most means less than or equal to, that is at most, but at least greater than or equal to. Then the other part here, the number of crackers, which is X. So our X should be more than, that is more than like this, or equal to, so there's more than or equal to like this, twice the number of rockets. Twice means 2 times like this, so it's going to be twice. So X is greater than or equal to 2y. Sorry, the number of crackers. Remember, our crackers is y. So guys, I'm taking the wrong letter here. The crackers is what? The crackers is y. So this is your y here. I hope someone saw that one. Say, okay, what is now happening? So the crackers is y. The rockets is what? It's x. Rockets here is x. So it's greater than or equal to 2x. All right, now it can make sense here. The number of crackers, that is the crackers, it's why I was just still like on the rockets. No, we are now on crackers, then combined 2 rockets. Okay, so these are the 2 inequalities on B. Then C now, use the 2 centimeter to present 2 units on both axes. Show by shading the unwanted regions now. All right, so this is what we need. As we can see, guys, we now need our graph so that we can be able to have this part. So I'm just going to check these inequalities so that we can use them on the other graph. Okay, so I think that is the best part. Let us have our graph here. So with this scale, guys, we are just going to take our scale here. Okay, 2 centimeters per 2 units. So let me see, guys. I'm just going to share you back to this screen so that at least we can be able to work from there. Okay, so I'm just going to refer to this screen. If you are to cross-check, I've got my graph here, and 0, 2, 4 at the scale, 2 centimeters per 2 units, and I'm given here 2, 4, 6, and so forth up to the last one. So I can even try to reduce it a little bit so that it can be up to 20 there. So this is your x-axis, and we've got your y-axis. So I'm just going to indicate also this one is our y-axis there. Okay, and these were the inequalities that we were given. 2x plus y is less or equal to 20, x is greater than 4, greater than or equal to 4, and y is greater than or equal to x. So according to what we're given, that's what you're going to do. And okay, we just have to see this part. Okay, so let us represent. We can just start with this one. X is greater than or equal to 4. So we need to draw the line of x is equal to 4 in this case, so that we'll be able to have this. So remember, the line of x is equal to 4 is actually at this point here. That is at exactly where x is equal to where we are given the values of x. So we are going to this point. Sorry, not that one. Sorry for that, guys. This is x, not y. Okay, so let me do this. Rotate until I get the y. So until I get the x, direct at x. So this is what I'm going to do here. At x here, this is a continuous line. Remember, it's greater than or equal to. So at x is equal to 4 here, I have to draw a continuous line here. Okay, let's hope it's not going to affect us. All right, something like this. So it must pass through that 4. Okay, to this side, just draw to the last part. So I'm just going to refer this down again so that it will be a little bit bigger. So you draw up to the last point. Just make sure that you're drawing something that is accurately. All right, something of this nature here. All right, so this is our line of x is equal to 4. This one, x is equal to 4. All right, so where are we going to shade now our graph? Remember, we are told that x is greater than, so these are the bigger values according to x, and these are the lesser. Remember, this is your greater and this is the lesser. So this is the region that you need. So you're going to shade this one. The unwanted region is the one that you shade. So always shade the unwanted region. So this is your unwanted region. You shade this side. You do not need this side here. All right, let us try to increase also here, shade out this part. So we're shading out, okay? So, and also you write the equation of the line here. You don't write the inequality. X is equal to 4, you write the equation, okay? Let's see this one. We're given that 2x plus y is less than or equal to 20. So what we need, we definitely are going to need our table values for the line of 2x plus y is equal to 20. All right, so you can use table values, but in this case, I'm just going to use double intercept. In this case, because I've got the factors direct here, I can just use double intercept to say that when x is equal to, so let me just try to reduce this one to this. Okay, so I can ask myself, this is x and this is y. Then we do the same on this part. This is your x, this is your y, okay? So when x is equal to 0 here, what is the value of y? Which means we are saying here on x, there's a 0 here. So y is equal to what? Y is equal to 20. So y is going to give us 20 here. We do the same on this part. When y is equal to 0, what is the value of x? It means now we are given a y which is equal to 0 here. So what is going to be the value of x? As you can see, 2x is equal to 20. So if 2x is equal to 20, what is the value of x? Divide by 2, divide by 2. So which means our x is going to be what? Our x is going to be 10. So this will be 10 here. All right, so double intercept, these are 2 points that you just need. You take these values 0, 20, and 10, 0 on your graph. So let us take our graph back here. So we said we need 0, 20, and 20. So let us start with the 0, 20. When x is 0, y is 20, which means at this point here, that's where we have our 0, 20 in the y-axis at 20 there. All right, and 10, 0, that is in the x-axis, where x is equal to 10 here, you mark this point. At x is equal to 10, you mark that point, okay? So that's double intercept, you join those points. So now guys, look at our point is at the top there, so I'm just going to reduce like this so that I can access that part again. All right, so let us take our ruler. all right, and try to shift so that it can be able to join these 2 points. Are we able to join now? Just a little bit, yeah, somewhere here. Yes, we are able. We can be able to join these two. So it's a continuous line because it's less than or equal to. So it's going to be a continuous line also. No, it's not directly at the point. Maybe a little bit. All right. So we just make sure that it's a continuous line, guys. Okay. Then you join these two like this, a continuous line because of the inequality. All right. So let's take our ruler aside in this case, okay? So from this part now, we want to see which region are you going to shade. Because remember, you'll be given your equation, you just write down your equation here is 2x plus y, which is equal to what? Which is equal to 20. That is our equation in this case. All right. So which side are we going to shade? That is the question now from this region. Which region are we going to shade? Are you going to shade this region or this other region? Okay, so this is it here. Remember the type of a line, you're given a line like this one. Okay, let's just take it back. You're given a line like this. Okay, so remember guys, I told you that this is your bigger region and this is your lesser. As you can see, these values, they are less than this value. These are bigger values. So which means as we need a region which is what? Which is less than, we need a region that is less, which means we need this region on this side. So we do not need this region on that side, okay? So which means we are going to shade on that bigger, on that side, which is bigger now, okay? So on our diagram, we are going to shade the bigger side, which is this side here. So this is the side that you're going to shade. So let us shade this side, okay? We're going to shade this side. We do not need this side here. We do not need this region. We do not need this region. So we just shade here. We do not need this region. We do not need this region. We just shade that side. Okay, so that is it for this line. 2x plus y is equal to what? That was 6. Okay, 20. Okay, 20 then we move on to the other one. We are now given the last one, y is greater than or equal to 2x. So this is one that we need. So you can have table values here for y is greater than or equal to 2x. Maybe I can just even have my table here. I can just create my table here. Remember, it's y is greater than, so I'm just going to take this as y is equal to, we write the equation, all right? Y is equal to 2x. Forget about the inequality when you are creating the table values or when you are drawing the line. Then you've got your values of x. So we're just going to have x and y here. You just pick 3 points on that table for x of your choice. So in this case, I'm going to just pick any at random from that table that I'm given. I'm just going to pick 0, 4, and 6, just of your choice. I'm just going to work with even numbers here so that at least it can help me. So this is, I said 0, 4, and 6. Okay, so this is what? 0, 4, and 6. So you pick any of values of your choice, okay? So what does this part mean? If x is equal to 0 here, I'm going to substitute x, which is equal to 0 in place of x here. So it means y is equal to be 0. When x is 4, I'm going to substitute 4 here. That's 2 times 4, which is 8. When x is 6, I'm going to substitute 6. That's 2 times 6, which is 12 in this case. So these are the points that I need to draw the graph now. So I'm going to take these points back on my Cartesian plane. That is 0, 0 at this point. I mark the point at 0, 0 here. 4, 8. When x is 4 here, y is 8. That is at this point 4 and 8 here. So that's where you're going to mark your point at this point here. All right, so let us just try to use this side. Then we have got our last point, which is in this case, we said is 6, 12. Okay, so we're going to mark when x is 6 here, y is 12. So it's going to be somewhere here, 6, 2, 4, 6, and 12. That's somewhere here. Okay, so this is your 6, 12 here. All right, so I'm just going to reduce so that we can be able to join everything properly. So these are the 3 points that you need to join: this one, and this point here. Okay. And also checking at the line is a continuous line. We're given greater than or equal to, so it's going to be a continuous line. So we're just going to join our continuous line. So we just need our ruler back here. All right, so let's try to rotate it so that it should be able to join these 3 points together. All right, seems like we can't join. I will be able to join, guys. All right? So I don't know if we be able. These 2 points, they're fine. It's 4. We say it is 4, 8, 6, and 12. Okay, 2, 4, 6, 8, 10, 12. So these are the points actually. So maybe it's because of the graph, because it's been, when you scan these papers, they tend to be something else. But this is what it's going to look like. Maybe somewhere there. Yeah, we just have to, let us just join them at this point a little bit. At this point, right? Why is it not giving me this part? Okay, so just going to join here. So let us join a little bit from this point like this, right? Like this, something of this nature here. All right, so you are going to remain with this region that you're having. Now, where are we going to shed? Let us get back to our line. Remember, the type of line that you've created is this type of a line. So let us know which region are we going to shed. Remember, if you are given a line like this is the bigger region, this is the lesser region. As we are given that y is greater than, okay, y is greater than or equal to 2x. So this is the region that we need on top. So we do not need the region below that line, okay? So we're going to shed the region below that line, okay? So this is our line. This region below this line is the one that you're going to shed, okay? So let us shed our region below the line, that is below the line. This is your line. We shed this region below, share this region below, share this region, we share this region. All right, so that's it. And also remember to write down the equation of the line. This is y is equal to 2x. So that is the equation of the line. In this case, y is equal to what? Y is equal to 2x. You write the equation, not the inequality. The inequality is just helps you to know which side to shed and so on. But on the graph here, all you do is to write the equation. Is equal to, you write the equation. So that is what we are going to have. And this is the region that is going to remain at the end, which is not shaded, which is in between here. So this is our region. We can just refer to this as R. Okay, so that is where our answers are going to be taken from. Our answers are going to be taken from that region that you see there. So make sure that the region is clearly indicated. You clearly see your region that you're going to work with, something of that nature. All right, so that was it. This part that is not shaded, this part that is not shaded is the one that you're going to work with. So let us get back to the question that we are given here. We are being asked now to use your graph now to find on this graph that you're given, find the combination that uses the maximum amount of money available. So we need a combination that is going to use the maximum amount. Then the combination, use the combination that uses the maximum. Then item 1, the combination that uses the minimum amount of money. So we need the one that is going to give us from the D item 1. We are starting with this D item 1. The one that uses what? Maximum amount of money. Okay. The first thing is, for us to have the maximum amount of money, our inequality has to be taken from this inequality that uses amount of money, this one that we reduced here. Remember, we had 60x plus 30y, which is less than or equal to 600. This is where we are going to have our answer from this inequality, because this is the inequality which involves what? Which has to do with the amount of money that this person has, which is 60x plus 30y is less than or equal to what? 600. So that is the first thing that you're supposed to work with. Now, which combinations are we going to take now? That is from our graph. So we have to go back to our graph and take the combinations now from that graph, okay? So from our graph here, let us take our graph back. Which combinations are we going to have at the end? We are going to have these combinations at the end here. This point inside or on the graph, these are continuous lines. So you can take this point here, this point, that is your first point, the one that I'm indicating here. This point, yes, is at, let us cross-check back on our diagram, which passes through a 5. That one is at 5, the in between, that one is 5, 10. All right, this point here at 5, 10, this one. And also this point, which is at 4, 12, this one. Okay, so these are the 3 points which are on the, you do not take inside the region, along the lines. That is where your answers are going to be taken from, okay? So we said we have got this one, the first one, it was 4. This is x, which is 4 here, remember. This is your 4 here. All right, so you've got 4 versus what? 8. So this is your first combination, 4 versus 8. All right, so this is 4 versus 8. That's our first combination, 4 versus 8. And we also have got this one. Here we said here inside is 5 versus 10. So that one is 5, 10. We have got 5, 10 in this case. And also this one here, which corresponds with 4. So it's 4 versus what? 4 versus 12. Okay, so this is 4 versus 12. So these are the only 3 combinations that we can use. Not to say any inside we can use them, but we need the ones that are going to give us maximum or minimum. So any answer that is to do with maximum or minimum, it has to be taken from the boundaries of what? Of the inequality of the region that you have used, which is this one. So you take from the boundaries of that region. That is what you're going to have in this case. All right. So which combination is going to give us the maximum or the minimum value? That is what is important in this case. Okay, so we have to get back to our region here. All right, that is, I don't know if this, let me show back. Okay, let me get back so that we can be able to take our question. All right, we need from this question here. All right, I think we are now back to the same question together now. We say the combination that uses maximum amount of money. So that means we have to take from any combination and substitute the values there. All right, I think it's easier for me to just write those combinations here. I think we still remember our combinations. We said we have got 4, 12. That was our first combination. Another one was 5, 10. All right, then another one, which is last one, was 4, 8. So now the question is, which combination are you going to use the maximum amount? So like I said, you take from what? You take from the this amount that we get, 60 plus that y, this one. So which one is going to give us the maximum? So you just substitute, guys, these values. You are saying this is your x, this is your y, this is your x, this is your y, this is your x, this is your y. So you're substituting in place of x a point. If you take this point, you substitute it in here, okay? So it's a trial and error question. It's not it's direct, it's trial and error. So you have to try. So let's try the first one. When x is 4, we have to substitute 4 here in place of x. So it's going to be 60 times 4 plus 30 times y here, which is 12, okay? So like I said, it's a trial and error. So this one is going to give us 600 if we do this. Is that so? Let me substitute 60 times 4 plus 30 times 12 in this case. All right, I'm obtaining 600. So this one is exactly giving us 600. Okay, so let's try 5y. So this one was from 412, this one. We move on to 5, 10. When x is 5, y is 10. So you have to substitute x is 5, so it's 60 times 5 plus y is 10. So it's 30y here, which is 30 times 10. All right, so this one is going to give us maximum again. It's going to give us 600, this one. And 4, 8, which is the last one, we're on 4, 8. When x is 4, so it's going to be 60 times 4 plus 30y, y is 8, so it's going to be 30 times 8, okay? And this one is going to give us 480. So, all right, so these two combinations actually are the ones which gives us the maximum amount, because we need where 600 cents was used, which is $6. So that is the combination that uses the maximum amount, okay? So in this case, we've got two answers, which gives us the maximum amount of money which was used. We said we've got 412 here. So we've got 412, first combination that we substituted, and this one of 510 when x was 5, y was 10. So these two combinations, they give us the maximum value, okay? Then on item 2, so this is now different from what we had. It's another question. The combination that uses the minimum amount of money. Take note, we need the combination, not the amount. The combination which is going to give us the minimum. So as we saw here when we were doing our trial and error, already the answer we have it. Our minimum value is what? 480. And the combination was from what? From x is equal to 4, y is 8, which is 48. So this is the combination that you're going to write here. So your combination here is 48. So you do not take anywhere, you take from that region that we had. Okay, and what is going to be the change now in item 2.1? From this item 2.1, when we used the minimum amount, what is going to be the change? That is what they're asking. And when we use the minimum amount, we saw that our minimum amount was 480 cents. So what is going to be the change? So our change, we have to just subtract the amount of money that she had. Remember, she had 600 cents. So this is the money that you already have, all right, minus the amount of money that you have used. So it's 600 cents minus 480 cents, okay? So that would be your change. So 600 minus 480 is going to give us 120 cents. So this is going to be 120 cents, or you can write this as $1,20, okay? So it's going to be $1,20, this one, or just 120 cents or $1,20. So that was it, guys, on this typical question that we had. Be very, very careful with the questions that you're going to be attempting, guys. It's very, very important that you understand what you have. And this question now is not going to be clear on our graph, guys. It's from minus, we are given 2 centimeters into 1 unit, and the scale is from -4 up to 6. So this one is not going to work for us. I want you to see something from our graph so that you can agree with me before. So maybe we just have to do it this. I don't know what is best. Remember, we need from -4 up to 6. So you can say -4, -2 here. This is, it's actually 1, 1, 1. So it's -4, -3, -2, -1, 0 here. 1, 2, 3, 4. So our graph is not going to be enough. So actually, this is a normal graph that we have, and this normal graph is not enough. I don't know what was what were they trying to do with this question. We just have to use that way that we used to have previously. That one, I think it can actually help us. Okay, so that is what we had, guys. As you can see, it's not actually clear. It's not going to be enough. So we are going to proceed to the other question. So this type of this question, I will see what I'm going to do. Work it on a different way, that is using our traditional way of having setup, that traditional setup that we used to have. Yes, I can maybe manage to win that one. I will just see what is best for us. Okay, so let us quickly rush to question 10. We are given the point M that we are given is got coordinates 7, -3. RM is 6, 4. That is what we are given in this case, and we are given to calculate the coordinates of what? The coordinates of M. All right, so what are we going to do in this case? How are we going to have the coordinates of the point M? So that's the question. I don't know if I managed to share the actual screen. Okay, but it's actually the one. So, all right, sorry for that, guys. So we are just going to apply our vectors. So remember your vectors, guys. To find R in this case, all you just need is to formulate your vector from Rm. All right, so that's what you're going to have in this case, because we are already given Rm. Where was this taken from? We know that our Rm was taken from OM minus R. So take note, it's M minus R like that one. So it's going to be OM minus OR, okay? We are given already our RM in this case, which is 6, 4. So we're just going to substitute the value that we are given in this case, which is 6, 4. Okay, is equal to OM. That is the point M now in vector form. So it is going to be 7 minus 3 in vector form minus OR. So finding this vector OR is this one, is finding the coordinate, because it's taken from what? From the origin. So we just have to make it positive, because as you can see, it's a negative here. So we're going to transpose it to the left-hand side so that it becomes positive. So OR is equal to 7 minus 3. Then we transpose this 6, 4 to the right-hand side, so that this one will be a negative because it was a positive. So it becomes a negative. So it will be negatives 6, 4, like that. All right, so this is your vector OR that you're going to have. That's 7 minus 6. You subtract corresponding elements. It's 7 minus 6, which is 1. 3, this one is -3, -4. So it's -3, -4 like this, which is your -7. So this is your OR, which is a vector taken from the origin. So therefore, R as a point is just going to be X and Y like that, which is 1 minus 7. So make sure you answer the question. So it's 1 minus 7, okay? Then vector MR. So we now need vector MR. So take note, we have got the point M, we have got the point R. In this case, we calculated this R, which is 1 minus 7. So where are we going to have our MR? We are just going to use the formula just like what we did here. So MR, in this case, this is our item 2. All right, so this is our item 2 here. All right, so MR is going to be OR minus OM. So it's going to be OR minus OM. So we need the point we see. So if you have got error here on your point R, it means this question is also wrong, because OR, we need that R that we said as a vector form, that's 1 minus 7 minus OM, which is the coordinate of what? Of point M that we have got here, and we are given that our M is 7 minus 3. So we're just going to take that one in vector form, which is 7 minus 3. All right, so we can perform our subtraction in this case. So what we're going to have at the end, we are subtracting corresponding elements, 1 minus 7, which is negative 6, negative 7, negative, negative 3. So it's like this, negative 7, negative, negative 3. All right, so that's it. Let's see, it's a negative 3 here in brackets. All right, so it's going to give us a plus. So it's negative 7 plus 3, which is negative 4 from your calculator. So remember, it's paper 2, guys. So it's a vector. This one, you leave it like this in a vector form. Okay, so that was our vector MR, which is minus 6, minus 4. So that's what we got here, negative 6, negative 4. All right, the B part now, we are given a vector, which is already drawn for us. We're given the shape that we are given here. Then from this quadrilateral that we have got, the diagram is a quadrilateral ORST, where we are given vector OR, that is OR, this one is U, and vector OT, which is 2V and 2U plus V. Diagonals OS and RT intersect at P, so this is the point of intersection, which is our P. Then the first equation, okay, just that's what you are just given. So let's get to the next page and see the questions there. Express in terms of U and or vector V, vector RT. Okay, so that's the first question. We need vector RT. So let's get back there and see our vector RT. So that is from R here to T. So which direction or route am I going to take to find RT in this case? So this is B item 1, item 1. So this is B1 item 1. So just going to write it here, B1 like this. Okay, so RT, I'm going to move from R to O, then O to T. That is the route that you're going to take. And this route that you take note, it's you do not use the signs when you are applying the route. You just take your route from R to O, and you start with this part, which is R here. So it's R to O plus, then you move from O to T, okay, plus OT, that is your movement in this case. This is where now you have to apply the signs, that is from R to O. What are you doing? You are opposing the direction. You are going this direction, but the vector originally was pointing at R, so you're going to put a negative on that one. So it's going to be negative vector U plus OT. From O to T, we are maintaining the direction of the arrow that we already have. So it is going to maintain the 2V as it is. Okay, so that is our vector RT. So you can even leave it like that, or you can write it as 2V minus U, it's fine. All right, then the second part, let's see what are we given. On the other part, OS. So we need vector OS. Okay, so we need the route again that we are going to use from O to point S. So this is vector OS. So what I'm going to take from O here, this is your O and this is your S. So as you can see, all vectors are there. We are given everything here. So we're going to take from O to T and from T to S. So that's OT. You start with O, then you end with S. Then plus, we are now at T. You move from T to S. So that is TS. All right, then you substitute your values. OT is 2V plus, we are maintaining here, and also we are maintaining the arrow here. So we're going to take everything as it is, which is plus 2U plus V. All right, so let us have in order. So it's going to be 2U here. 2V plus V, this is same as 1V, so it's 2 plus 1, which is 3V. Okay, so this is our vector OS. Okay, we're done on this part. Let's see the other question. Okay, let's just do this. Okay. Let's see what we are now given. So make sure that you understand the concept of vector. And because vector, it's a hence method, whatever that you do, it's a continuation that you're going to make. Okay, on the item 2, 1 now, which is we are given OP is equal to KOS. So the letters start by this. Okay, expressed in terms of K, which is the constant. So this K, remember guys, I told you that this is a constant that you'll be given, or a scalar. All right, so this is just a constant or a scalar which multiplies a vector. So OP is now written in terms of what? In terms of K. So let us get back where we are given that OP is equal to KOS. All right, so this is what you're going to do here. OP, all right, like this. We can even put it this way. All right, so we said this is 2A item 1, 2 item 1, 1. Oh, it was 1 like this. Okay, but it was OP. We are given that vector OP is equal to K times vector OS. Okay, do we have vector OS? Yes, we found this one, vector OS here. So we're just going to substitute that vector that we obtained. So OP is equal to K times vector OS, which we got as 2U plus 3V. So that is the vector that you got here, which is 3V. So you can multiply by the constant, or you can leave it like that. Okay, so if you multiply by the constant, you start writing the number, the constant, then the vector. So it's 2K vector U. K times 3 here is going to be 3K vector V. So like this would be your vector OP. So that is what we are given in this case. All right. Then the second part, in terms of the same thing that we have, then item 2 now, RP, ensure that it reduces to, we are given the answer for RP, vector RP. Okay, so what we need is to combine to find our RP from those vectors that contain K. As we can see, our answer is in terms of K. So where are we going to have our RP? Okay, so far the part that has got K is this OP that we determine. So OP is supposed to be part of our root to find vector. It was RK. Okay, let me cross check from the present paper that I'm having here is RP. Okay, that was RP. So this is number 2, which is RP. So which root are you going to take from R to P? But OP is supposed to be there. Okay, so this is our R here to P. So I'm going to use this root because I need to involve OP in this root. Okay, remember I'm given OP. So this is what I'm going to do from R here to O, then from O to P, because I now have this OP. Okay, so that's the root that you're going to take, RO plus OP. Okay, so that's RO plus OP. So let's just write it here. That's RO plus OP. Okay, so do we have vector RO? Yes, definitely, because that's the root that we have taken with everything. So our RO, remember, it opposes, so it's going to be minus U, like what we did previously. So it's going to be minus vector U plus OP, which is now in terms of K, and this is your OP in terms of K here, which we said is 2K vector U plus 3K vector V. Okay, so let me just stop for a second. Let me just stop for a second here. All right, so it's a 3 kV like this. All right, so that's our vector that you're going to have. And according to the way that they wrote, we saw that it was a positive. So I'm just going to start with this one with a positive because I'm supposed to factor out vector U, which is common here. We can see that there's U here, there's U. So you factor out the common vector, not the constants. You do not factor out the constants. No, you factor the vector. So this is what happened. We had to factor vector U like this. So if we factor vector U, what are you going to remain with here? You're going to remain with plus 2K. Here you're going to remain with minus 1. This is same as minus 1. So you're going to remain with minus 1 plus 2K plus 3K vector V. All right, so this is our RP. But according to this, we can just start with the positive, which is going to be 2K minus 1 vector U plus 3K vector V. All right, so this is our RP like this. That is our vector RP. So that is how you simply have your answer. So as you can see, this is exactly what we are given to show that is going to reduce to this part. So we are done on this part. We move on to the item 3, which is now given that it's another statement. RP is equal to HRT. Express RP in terms of HU and so H is supposed to be there. So we need this format first. So we are given that RP, this is item 3. All right, so let us first write our RP, then we substitute the information if we have got our RT, that is if we have calculated this. But if you haven't calculated RT, that means you have to calculate it, or it might be on the diagram. Okay, so it depends. Sometimes it might be on the diagram. Okay, let me adjust to the diagram and see RP. Okay, RP, do we have, it was RT, not RP, RT, yes, we calculated RT here. This is where we calculated our RT. Okay, let me write the question, let me write the statement first before I do this part. Okay, so this is item 3, it was now item 3. Okay, and we were given that RP is equal to K RT. This is what we are given on that statement. So K, it was H, not R. It was not H, not K. So this is H. So it's going to be H times vector RT. And we said we have got our RT here. We calculated RT before. And our RT here gave us minus U plus 2V. So it's going to be minus U plus 2V. So this is what you got here, minus U plus 2b, like that. So that's your vector. Yes, you can multiply by your h, which is a constant, so it's going to be minus h vector u. H times 2 here is going to be 2h vector v. That is, if you want to extend your vector further, you can even write it this way. So it's minus hu plus 2h vector v. So that's what you're going to have at the end. Let's see the other question now. What are we given? Item 4, we are now given here using the results of item 2, that is this item 2 here, where we calculated RP, this one that we have got here, and item 3, where we've got our RP in terms of H. Calculate the value of H and the value of K. All right, so this is what you're going to do. From our previous answers, this is item 2, this one, our item 2 here, that was our item 2, this one, and so item 2 like this, and this is our RP. So we have got 2 RPs that we have got. Vector RP, this one that we got from our item 2, from the first one, that is our RP, and this RP that we have. So what do we know? These 2 vectors, they will be equal at the end. So this is our item 3, okay, item 4, not item 3. Okay, this is our item 4 here. All right, so we now have our item 4. So what are you going to do? We are going to take those 2 vectors which are equal. The first one, RP, which is equal to 2k minus 1, minus u is minus 1, not minus u, minus 1, minus 1. All right, so this is negative 1 here. Okay, so it's 2k negative 1 times vector u plus 3kv plus 3k vector v. All right, then the second RP that we got here, we write it as it is, which is minus hu plus 2h vector v. So make sure you write the u to starting with u followed by v. Okay, make sure you maintain this order. This is u, v, u, v, like this. Okay. So remember, guys, I told you that whenever you are dealing with this type of equation, for you to find the values of the scalars, which is h and k, you equate the vectors which are the same, vector u here and vector u here. What are you equating actually? You are equating the scalar, the constant part, this one, that is multiplying the vector, which is 2k minus 1. You equate that one to the scalar, which also affects the same vector, which is vector u, and that scalar is negative h. So you have formulated an equation, you leave it like that, okay? You move on to v. This is your vector v here, your vector v here. What is the scalar here that we have is 3k. Our scalar is 3k. What about the scalar here? It's a positive 3h. So you equate to positive 3h. What have you done? You have formulated an equation that you're going to solve for h and k. All right, was this negative? Was this 2 or 3, guys? Let us just cross check back our questions. I want to make sure we've got a clarity here. Was it a 2 or it was a 2 here, not a 3 here? I was surprised why these 2 numbers are now the same. So this is 2HV here. I hope we saw that part also. Guys, we must move together, okay? We must move together. Even if you find any error after the question paper, you must be free to let us know where there's an error so that we can indicate it on the comment section, so that we'll be able to help others. Maybe they couldn't manage to see any error. So please do so, okay? Anyways, these are the two simultaneous equations that you have formulated. These are now equations. So you are going to solve your equations. On solving, I want you to be note here. I want you to take note here. On solving these equations, it's up to you. Which method are you going to use? I don't know which method you want to use. Substitution method, element, but you now have simultaneous equations, all right? So depending with the method, but this one I'm just going to use the one that you are used to, guys, of rearranging this, taking the h to this side so that I can have a normal equation. So it's going to be 2k. The minus h, when it crosses the equal sign, it becomes a plus. So it will be plus h is equal to, I transpose the negative 1 across the equal sign, it is going to become a plus 1, okay? I do the same on this one, is 3k here, transpose the 2h to the left-hand side is going to be negative 2h is equal to, what is remaining here? Nothing, so it's going to be a 0 there. So I have two equations that I'm going to work with. I'm just going to name this equation 1 and this is my equation 2. So I've got equation 1 and equation 2. Depending, I'm going to use elimination. Eliminate the part of k here. I just have to interchange the coefficients of k, which is 2 and 3. So these are the ones that I'm going to multiply with. Multiply on top by 3. Multiply on the bottom by 2, you just interchange these two, okay? So it means you're multiplying everything by 3 on top. So 3 is going to multiply everything, that's 3 times 2, which is 6k. 3 times h is same as 1h, this one, so it's going to give us 3h is equal to 3 times 1, which is 3, okay? We are done with the 3 part, we move on to the 2. 2 is going to multiply everything, again, 2 times this 3, which is going to be a 6k. 2 times negative 2 here is going to be negative 4. So that's a negative 4 here. So we are going to have negative 4h. 2 times a 0, that's a 0 there. Hope everything is fine. Okay, so let's see. How are we going to eliminate our k here? Because we've got 6k and 6k. We are going to subtract. So you try, it's a plus or a minus. Definitely, these are the two sides. So you can try by adding 6 plus 6, that's a 12, which means you haven't eliminated k. So you have to subtract, okay? So if you have to subtract the equation 2 from equation 1, you're going to obtain a 0 on k. So 6 minus 6, that's a 0 here, you're done. So you've got 3h minus and minus. So take note, it's a minus and a minus, this one, which is going to be a plus. So it's 3h minus 4h like this. So it's going to be a plus, which is a 3 plus 4. That's 7. So you're going to obtain 7h is equal to 3 minus a 0 here, which is going to give us 3. Okay, so how am I going to find h? Divide by 7 both sides. So h is going to give us 3 over 7. All right. I have the value of h. I now need to find the value of k. I can substitute into any of these equations. I can even start from these ones. So as for me, I'm just going to take this one. It's best for me to use this one. You just choose one that is best for you. So 3k is equal to 2h. I substitute the value of h, which is 3 over 7. So 3k is equal to 2 times 2h means 2 times h. So it's 2 times h, which is 3 over 7. This is same as 2 over 1. So 3k is equal to 3 times 2, that is 6 over 7. Okay, so let's see. Let me just store for a little bit. So this one is going to give us a 6 here. All right. Okay, let me remove this marker. So it's 6. Okay, I haven't indicated the marker. Let me place back. Okay. All right, so this is going to give us 6 over 7 in this case. All right, so I need the value of k. So what am I going to do? Yes, you can do cross multiplication, guys, and this and that, but the 3 is multiplying. So how do you remove this 3? Simply what? Divide. You're multiplying, simply divide, simply divide. So this can cancel here. K is equal to, so how do you divide this? On your calculator, or you can simplify 6 over 7, divide by 3. That is what it means. Or you can just divide this 3 can affect this 6. So it's 3 into 3, 1, 3 into 6, which is 2. So it's going to give us 2 over 7. So this is the value of what? The value of k, and this is the value of what? The value of h. So that's how actually you attempt these questions on solving for the unknown values, which is what? Which is the scalar or the constant. Remember, we said it's a scalar, or it's referred to as a what? As a constant. All you need is to formulate 2 equations. Then you solve those equations. So that is the part. Okay, let's see the next question. Now we are on number 11, so I think this part was done because as you can see, we've already, that is the last part, and we've got 9 marks on this last part. Okay, number 11, we are now given simultaneous equation. Just look guys, simultaneous equations, the one that we just solved now. So I don't know which method I'm going to use, but here it was clearly easier for us to use elimination, just interchange 3 and 5 here, multiply on top by 5, on the bottom by 3. So you're multiplying everything. So it's 5 times 3, which is a 15x. 5 times minus 2, that's negative 10y, is equal to 5 times 4, which is a 40 here. All right, so you're done by multiplying by 5 for everything. Here by 3, so it's 3 times 5, which is a 15x. All right, 3 times negative 4 here, that's negative 12y, is equal to 3 times 12, that's going to be 36. Yeah, this is 36. Let's see what we're going to have. How are you going to eliminate? Add, you get 30, so which means you can't eliminate by adding, so which means you have to subtract. So you're going to subtract the second equation from the first one. So 15 minus 15, that's a 0 here. Now this part, take note, this is negative 10y, this one, so it's negative 10y like this. Then we move on to this negative, so it's negative, then to this negative, so it's negative 12y like this. So negative and negative is going to give us what? A positive here. So it's now negative 10y plus 12y, which is going to give us 2y. So this is going to give us 2y here. 40 minus 36, this is directing, which is going to give us 4. So you can divide by 2 both sides. 2 both sides. We've got the value of y here, which is a 2. All right, now substitute the value of y, which is 2, into any of the equations. You just choose. I'm just going to take the first equation as it is. 3x minus 2y is equal to 8. Y is equal to 2, so I'm going to substitute in place of y here for 2. So it's negative 2 times 2, which is negative 4. So I'm going to remain with 3x. Transpose the negative 4 to the side is going to be a plus 4. So that means I've got 8 plus 4, which is 12 in this case. Okay, so how do I find x? Just divide by 3 both sides. So this can cancel. I've got x, which is equal to 3 into 12. That is a 4. So that is what I'm going to have here as the value of x. So guys, as you can see, it's a matter of understanding the concept that you're given solving. So you can choose any method, but these are the answers that you must get from your solutions. So just try any method, guys. Let us know if you're obtaining different answers. Okay, then the B part is bearing. So whenever you're dealing with the bearing, I want you to be very, very clear on bearing. Bearing is nothing, guys. You know you're solving triangles. The bearing only works on maybe finding the angles. That's where you apply your bearing part, okay? But everything is solving triangles, okay? So here we are given that there's in the diagram, 3 points are given P, Q, R, such that P is 4 kilometers, okay? This is P, which is 4 kilometers, all right, north of Q. So it's okay, P, sorry, we have P, not this P is 4 kilometers north of Q. Okay, so this is what we see here, the straight line from P to Q. Okay, that is it, 4 kilometers. And R is 6 kilometers from P on a bearing of 0.73. That is 3-figure bearing, this one, which is taken from the north in a clockwise direction. So that's 73 to point R. So we know that at point R here, we are just going to have our north pole, something like that. We just indicate. Maybe you might need it. All right, then that's the only information that you're given in the first equation. Calculate QR, that is the distance from Q to R. This one, remember, this is your point R here. So we need this distance from Q to R, okay? So as you can see, bearing has nothing to do with this part. All we need is to know, okay, this is triangle that has been formulated, and I can find this angle here. Why? Because I know that angles on a straight line, they add up to 180 degrees. So it's just 180 degrees minus 73 degrees so that we can obtain the remaining angle of 107 degrees. So this will be 107 degrees, okay? Now the question is, using this triangle, how am I going to find the third side? You are given an angle and you are given these two sides. Remember, you want to calculate the third side, you can apply your cosine rule. So that is where our cosine rule can be used. So this is item 1 of B. So remember, our cosine rule says that A squared is equal to B squared plus C squared. minus 2BC cos of what? Cos of A, whereby A is the angle that is in between these two sides, B and C, and A is the side that you're calculating, and you're calculating QR in this case. So it's going to be QR squared is equal to the B and the C are the sides that are creating the angle, which is this side and this side. So that's our B and C. So we're going to have 4 squared and 6 squared there. So it's going to be 4 squared plus 6 squared minus 2 times B times C. You repeat those sides, 4 again, times 6, all right? Cos of A, which is the angle in between those sides, and this angle is what? 107 degrees. So that's your cosine rule, guys. So you can move on. QR squared, 4 squared, that's 16 plus 36. So this is a 36 here. Negative 2 times 4 times 6. Okay, let's see. We're going to obtain 48. So this will be 48 cos of 107 degrees. Then if we add here, we are going to have 16 plus 36. That's something like 52 minus 48 cos 107 degrees. So just indicate for exam clarity, guys, okay? For the one that is going to mark your paper, just indicate for him or her the value of cos 107 is very, very important just for you to indicate that. So 52 minus 48 times cos 107 degrees, you just indicate that value that you're going to obtain on your calculator. All right, it's very, very important. So this is 107. Make sure that your calculator also is in degrees. So this is going to give us negative 0, something like that. Okay, negative 0,2. 9, 2, 3. Okay, you indicate everything to the last digit. So this is a stage of just indicating what you got from this, because you remember, guys, when you are writing, some of you, your 7, like mine, this one, you see this 7, how am I writing my 7? This 7 is supposed to be like this. So now, for that clarity, just make sure that you have, because there's no way that you can use a wrong value here and you obtain the same cost. There's no way like that. So that is the importance of doing this. But what are you going to do? You are just going back to this stage, okay? Insert these values on your calculator, everything from your calculator, insert everything. That is what you're going to do. So if you simplify that, make sure that it's in the degree mode. Your calculator must show a D. If it is not, if it is having something like an R there or a G, reset your calculator immediately, okay, so that it goes back to the degree mode. Okay, so that's what you're going to have in this case. So if you're going to obtain something like 66, 03384, something like that, up to the last digit. Then to find the QR, there's a square here, so I just have to introduce the square root both sides. So that will be my QR. So QR is equal to the square root of this is going to be 8,12612, something like that, up to the last digit. And remember your degree of accuracy, guys. Whenever it is not specified, leave your answer to 3 significant figures. Okay, so that's what you're going to have. So to 3SF, I'm going to have 1, 2, 3. So this 6 is bigger than 5, so it can round off this 2 into 3. So it's going to be 8,13. The units here, we've got kilometers, so it is going to be kilometers. So that's our QR in this case, which is 8,13 kilometers. All right, so that's what you're having here. Let us just put it back. Maybe we might need this value later on. We do not know, so it's best for us to just indicate that. Okay, so just going to indicate. So we said we got 8,13. So this is 8,13 kilometers. Okay, so that's it. Let's see the next question, which is item 2. Calculate angle PQR. Okay, so this is angle PQR. PQR, that is here. We've got PQR on this one. PQ to R, that is the angle that you're supposed to calculate this one. So how am I going to find this angle? Now I can use any cosine rule, can work, even sine rule, because I'm having an angle that I want to calculate, which is opposite a side. I've got this angle and this side, so which means sine rule can work, even cosine rule. So I don't know which one was going to be best for you, but as for me, I'm just going to use sine rule. We are calculating an angle this time, so make sure that for sine rule, an angle is supposed to be on top. So that is item 2 here. Since you are calculating angles, so it's sine A is over A is equal to sine B over B, which is equal to sine C over C, and so on and so on. Okay, so I'm just going to take these two parts. Okay, so the sine A, that is the angle that I'm calculating. So in this case, I'm calculating this angle at Q, this one at Q, and the side which is opposite is 6. Okay, so I'm going to write this angle as it is sine PQR over 6. Okay, so this is sine PQR over 6, sine PQR over the side 6 is equal to, I have to take the other combination, which is complete from the diagram, and the complete combination is this one of 107 and 8,13. So this is what I'm going to take, 107 and 8,13. So it's going to be sine 107 over that side that we got, which is 8,13. And it is best for you to use the exact value that you obtained here before rounding off. Here you've got the value that you obtained. It is best for you to use that. So you have to store those values in your calculator. Okay, but I'm just going to work with this one that you've got. So what am I going to do? I need this value of PQR. So what am I going to do to remove this 6? It's dividing. Take note, the 6 is dividing. So how do I remove it? I just multiply by 8. Remember, if you are multiplying, you divide. So if you are dividing, you multiply. So this will cancel each other. We are now left with sine PQR, which is equal to, if I multiply this is same as like over 1. So it's just the same as writing as 6 sine 107 degrees over 8,13. Okay, so that's it, guys. As a decimal fraction, what am I going to have? Express this as a decimal. You are going to obtain 0, that's what you're going to have, something like that, 0,70609. So write everything up to the last digit. This is what you're going to have up to the last digit. Okay, write everything. And from that part now, what you need is to find PQR, which is the angle now, this angle here. So how do you find this angle now, which is PQR? It's just like what you got, guys. Remember, I told you that if you're given maybe sine theta is equal to 0,5. For you to find this theta, you write on the other side as arc sine 0,5. So it's the same concept. We need the angle PQR. So this one is going to be written as arc sine 0,7069, whatever that you have, everything to the last digit. Okay, so on your calculator, what do you do? Without rewriting this, like you do not need to rewrite on your calculator. You just, on your calculator, second function, sine, or it's a shift and depending with your calculator, then you press the answer button to that answer that you got before. So it will give you the exact value instead of rewriting this one. Okay, so that is what you're going to do. It's only that this software doesn't allow me to apply the calculator. I'm just going to see the best so that you can understand what is happening. Okay, so that is it, guys. Arc sine of this is going to give us something like 44,918, something like that to the last digit. And this is an angle. I told you guys, if you're dealing with an angle, round off to 1 decimal place. So PQR in this case to 1 decimal place, you look at this 9, the following digit is 1. It cannot change this 9, so it's just going to remain like that, which is 44,9 degrees. Okay, so that is what you're going to have on PQR. That is 44,9 degrees here on your PQR here. That is 44,9 degrees. All right, so that's what we got in this case. Let's see the other question. Then on item 3, we need the bearing of R from Q to the nearest degree. So to the nearest degree means what? To the nearest whole number. That is what it means. You are dealing with a whole number to the nearest whole number. That is to the nearest degree. Okay. So we need the bearing of R from, take note, from, that is where we have to start from Q. So this is what we need. This is our Q here. This is where our Q is. All right. Take note, this is your Q here. And you need the bearing of R here from this Q. So it is taken from the north in a clockwise direction, going to R like this. So this is the angle that you're just going to take. This one that we just got, which is 44,9. But take note, we are given to the nearest degree. So which means we have to round off first so that it can be to the nearest degree. Okay, so I'm just going to put it here like this. Okay, so this was item 3. That was our item 3. So we said we are going to take that angle as it is which was 44,9. So to the nearest whole number, which is to the degree, is going to round off, and this will be 45 degrees. But this is 3-figure bearing, so it must have 3 digits. So it's going to be 0, 4, 5. That's how you have it as a 3-figure bearing. That would be 0, 4, 5 degrees. Okay, so that's what we had, guys, from this part. As you can see, these questions actually, they need us to do much revisions, guys, so that we clearly understand what is actually happening here. You need a lot of revision, understand your diagram, the information that you're given. But as you can see, it's actually nothing in this case. All right, so that was it, guys, and the calculations that we had. We are just going to move on to the other question and see what we were given. All right, now we are given on number 12, that is, all right, let us put it this way. This is, actually, these are cumulative frequencies that we are given. Number 12, answer all of these questions on a sheet of graph paper. The table below shows the distribution of mathematics marks for 500 students, okay, in an examination. And already you are given the mark and the cumulative frequency. Take note, guys, we are already given the cumulative frequency, and you want to draw a cumulative frequency curve. Remember, I told you when you are drawing a cumulative frequency, this is how it looks like, a cumulative frequency curve. It is drawn here using the upper classes. From those classes, you take the upper classes, and this part will be having the cumulative frequency. So on this table, there is no adjustment that you're going to do. You're going to take your cumulative frequency as they are, because already you're given, and these are upper classes, 10, 20, 30, whatever that you have there. They are upper classes. That is what it means. And if I'm to cross-check here, this graph here is starting at 10 versus 10. Here it's 10 versus 10, okay? And I want you to see what is happening. We are saying this is an upper class here, which means from this class is 10 to 20, from this class is 20 to 30. As you can see, there's a difference of 10, a difference of 10, a difference of 10. It means the first class was starting from 0 to 10. That was your first class. It's not there, this 0 here, because it's a lower class. That is why it's not indicated here. It's a lower class. But what are you going to do? You are going to take that lower class to be an upper class with a cumulative frequency of what? Of 0. So you're going to take it with a cumulative frequency of 0. Why are we doing this? Because we can see the graph is starting at 10. So we are going to have a graph like this, starting at 10 like this, or maybe you choose to use this point, which will start at 10 like that. We need a graph that is going to start from the ground, from 0 here. So what do? You just take your lower class so that it becomes an upper class, just like these classes, with a cumulative frequency of 0. By doing that, your graph will be at 0. All right, so that's what you're going to have. So I'm just going to put a graph so that we can work from that graph.